Chalo, now let us start the other part of our syllabus, that is design of reinforced concrete structures. Reinforced concrete, design of reinforced concrete structures. Shall we start the session? आज ये डिस्कशन करते हैं. अरे डिस्कशन में पूरा टाइम वेस्ट नहीं करना है यार. Right? Shall we start the new lecture? Chalo. So let us start the new lecture. Design of reinforced concrete structures. So see, this particular portion is totally theoretical. This is theory portion. There will be some numerical also, plus bit of numerical also, but you will expect more 1 mark question from this. Sometimes 2 marks question is also there. So both type of questions you will get, but mostly this is a theoretical portion. Okay, so try to grab whatever I'm saying. Okay, so जो चीजें मैं बोल रहा हूँ उसको grab करने की कोशिश करना. I will write as much as possible. Other than that, if I'm saying something, that also you can write by yourself, or you can see the recorded lecture again for more understanding. But whenever you have doubt in any concept, please tell me. I'll immediately explain that concept again. Okay, so starting your new chapter, that is design of reinforced concrete structure. Mostly you will expect 1 to 2 marks question from this particular course. Okay, so first thing first, what is your concrete? What is your concrete? So concrete is nothing but it is the mixture of sand, gravels, cement and water, which results in the solid mass. Now all of you are aware that how a concrete is made. So concrete is made by putting the aggregates with cement and water. These are my aggregates. Aggregates are nothing but your sand and gravels. And then we are putting cement also. And we are putting water also. Right? With that, we will get a hardened mixture. So we are putting cement and we are putting water. With that, we will going to get our concrete. Now, what is reinforced concrete? What is your reinforced concrete? Now, as you know that reinforced concrete is nothing but it is concrete plus reinforcement. Reinforcement means nothing but your steel bars is equals to your reinforced concrete. Now, why do we need these steel bars? What is the reason for providing the steel bar? Why cannot we provide the concrete itself only? So, because the concrete is strong in compression. but weak in tension. Concrete is strong in compression and weak in tension. Meaning of this, let's say if I have a concrete sample, this is my concrete, let's say 1 cube I made out of this concrete. Okay. If I'm applying the compressive force on the concrete, if I'm applying a compressive force on the concrete will have a very good strength in the compression. We can achieve the strength, let's say 20 mm or 20 MPa Newton per mm square, 200 Newton per mm square. This much strength in the compression for the concrete we can achieve. But if you pull this particular block of concrete, if you're pulling this particular block, then it shows very less strength. It shows very less strength. So very less strength in tension. The strength will be hardly from your 2 MPa to 10 MPa. From your 2 MPa to 10 MPa. That will be 1/10 time of your, approximately 1/10 time of your compressive strength. 1/10 time of your compressive strength. Why concrete is weak in tension? Because these particles are bonded. These particles are bonded through the cement. That bonding is not having good strength in the tension. Now, if it is not having good strength in the tension, then what we can do? Then we have to provide us another material which is good in tension. So that is why we provide the reinforcement, steel bars oblique reinforcement. Reinforcement or steel bars. So it is very good in tension. Reinforcement bar can easily take the tension and it is very good in the tension. And hence, if we are combining concrete plus reinforcement, then it will be very good in compression and very good in tension. So this mixture will be good in both resisting the tensile stresses and resisting the compressive stresses. That is why we use the reinforced concrete. Correct? Now, the next question will come that where to put this reinforcement? In the concrete, where should I put this reinforcement? See, for example, if I have a simply supported beam, this is my simply supported beam. Correct? If it is subjected to a UDL, this is my UDL W. This is the length L. Now, you already know for this particular beam, we have a parabolic BMD. This is my BMD. Right? And this ordinate is your WL square by 8. Correct? Now, positive bending moment diagram means it is a sagging. So, if this is my beam, so here I am going to have the sagging moment like this. Because the BMD is positive. Now, due to the positive bending moment diagram, on the top I will going to get the compression and in the bottom I will going to get the tension. In the top I will going to get the compression. In the bottom I will going to get the tension as explained in the last class. Now, here you see where the concrete is producing tension or where where the external loading is producing the tension. So here the external loading is producing tension on the bottom, and hence we will provide our reinforcement in the bottom. Reinforcement is provided at the tension location. That is why reinforcement is provided at the tension location. Meaning of this, if this is my beam, like this. For example, this is our beam, right? So how we will provide the reinforcement? We will provide the reinforcement at the bottom like this. Like this. So this is the location of reinforcement. Location of reinforcement. Now, if this is clear, then please tell me, if I have a cantilever beam subjected to the UDL WL, where should I provide the reinforcement in this case? On the bottom side or on the top side? At the top. Absolutely correct. Why at the top? Because we already know that the bending moment diagram for this is like this. This is your negative. This is my bending moment diagram. This is negative. Now, if this is negative, then it is going to go in the anti-clockwise direction, or it will have the hogging. So once it is having the hogging, that means you will have the compression on the bottom and tension on the top, right? That means we will provide here your reinforcement. That is why we will provide the reinforcement on the top. This is your direct objective question. Okay. So this concept is important. Where should we provide the reinforcement in case of a cantilever beam subjected to UDL over a span of L? He will give 2-3 locations. So based on the option, you have to judge where we have to provide. क्लियर है? कोई डाउट इसमें किसी को? Now is the concept clear to you? Where should we provide the reinforcement? Perfect. Now, if this is clear, then now we will see some of the properties of concrete. Properties of concrete. Now, what are the properties we have? Kushal Gera, overhang is same as cantilever at the top. Yes, in case of overhang, see, you just have to see your BMD, Kushal. If your BMD is hogging, you will provide on the top. If your BMD is sagging, if your BMD is positive or sagging, you will provide at the bottom. Perfect. Now, let us see further is your properties of concrete. So under the properties of concrete, the first property we have is called as a grade of concrete. The first property we have is the grade of concrete. Now, what is the grade of concrete? See, you might have seen like the grades as M20 grade, M30 grade, M40 grade concrete like this, right? Now here, your M represent the mixed design. M represent your mixed design. And this number 20, 30, 40, this represent your compressive strength. This is your compressive strength. So if I write M20, that means my compressive strength, FCK, compressive strength is going to be 20 Newton per mm square. 20 Newton per mm square. Right? This might, all of you might be knowing this. Perfect. Now, in the grade of concrete, we see we have M and 20. 20 represent compressive strength. Now, what is the compressive strength of concrete? Compressive strength of concrete. Compressive strength, it is nothing but it is sigma is equals to force divided by area, where your force is force at failure and A is the area of the object. Now, whatever be the object we will have, that area, that is going to give us the compressive strength. For example, how do we test the compressive strength of concrete? We test the compressive strength in your UTM machine. UTM machine is nothing but universal transforming machine or universal testing machine. Universal testing machine. Now, in this machine, we can have two types of, we can have the, what we call, under universal testing machine, we can have two kind of samples. One sample we can put as your rectangular sample, or we can say cubical sample. So this is your cubical sample. And one we will have is your circular sample. We call this as cylindrical specimen, cubical sample, or we call this as cylindrical sample. Cylindrical sample. Now, what is the difference between cube, if we make the cubes of the concrete and if we make the cylinder of the concrete? What will happen? Before to that, first you need to know For the concrete, we use IS 875. This is the code for concrete, Indian Standard Code. This is the Indian Standard Code for the design of reinforced concrete structure. And this is very, very important for you. This is very, very important for you. Why? Because we will going to take all the values from reinforced concrete structure code. Sorry, this is IS 456, not 875. IS 456 2000. 875 तो आगे आएगा. IS 456 2000. This is your code for design of reinforced concrete structures. IS 456 is the main Bible or the main code. IS 456 is the main Bible or the main code through which we design our all the structures. So in the entire course, I'm going to refer you that as per the IS 456, this value is taken. As per this, this value is taken, like that. Correct? Now, our IS course suggests that we should do the cube sample testing only. This is the IS 456. And IS course suggests we should have a cube size of 100 mm by 100 mm by 100 mm. On that cube size, we should do the concrete testing, and whatever the results we get, we should take those results if the sizes are like this. So, so you will make a 100 mm by 100 mm by 100 mm cube, and you will test that into the UTM machine or in the universal testing machine, and accordingly you will get your compressive strength. Clear here? Now, together with this, since we are looking at the codes only, we will see that there is another code which can be important for you in the exam. That is your IS 800. IS 800. See, you need not to remember this year, because it is the year in which the particular code was published. So they'll never gonna ask you about the year of publication. However, they'll ask you what is the code number. So IS 456 is used for concrete. Similarly, we have IS 800. It is used for design of steel structures. Design of steel structures. Similarly, we have few more IS codes that we will that I will tell you whenever it will be used during the class. But for now, these two codes you should remember, because directly a question can be asked on these two codes. Which code is for your concrete and which code is for your steel? Now, as per our IS 456, the grade of concrete is classified under three categories. That is your M10 to M20 grade of concrete. Then we have M20 to M25 to M55 grade of concrete. And then we have M60 to M80. So this is your this we called as a ordinary concrete. This is your ordinary concrete, and M25 to M55 will be your standard concrete, and this M60 to M80 will be your high strength concrete. High strength concrete. As the name itself is suggesting, see M60, 80. That means they are on the higher side than the M10 and 20. That is why it will give us the high strength in the concrete. क्लियर है पहली प्रॉपर्टी कंक्रीट की क्या है? कंप्रेसिव स्ट्रेंथ. Okay, guys, just give me 2 minutes. I'll be back. Okay, I'm just getting an important call. Just give me 2 minutes. I'll be back. Okay, so let us start our class. सृष्टि बोल रही है in the building materials we studied cube size. See, cube size can be of 150 also, 200 also, 300 also, 400 also, depending on the laboratory to laboratory. Okay, but IS code recommends what size? IS code recommends 100 by 100 by 100. That is important. What IS code recommends. Okay, now second property we have is the modulus of elasticity. All these properties we are looking for the concrete. Okay, so modulus of elasticity for concrete is given by E is, we know already that E is for the concrete, and C we represent that is for the E is modulus of elasticity and C is your for concrete. That is equals to 5000 root FCK. This is very important formula, and directly they can ask you a objective question based on this formula. Okay, where FCK is what? FCK is nothing but it is your compressive strength of concrete. It should be in your MPa. Then the EC value you will get in your MPa. For example, if I have a M25 grade of concrete, so for M25 grade of concrete, my EC is going to be 5,000 square root of 25, right? Because M25 means FCK is your 25 MPa, Newton per mm square. So from here, I will get my EC as 5,000 into 5. That means my EC is going to be 25,000 MPa, Newton per mm square. This is how we calculate the modulus of elasticity of concrete. अब आप मेरे से पूछोगे कि सर ये फॉर्मूला कहाँ से आया? ये फॉर्मूला आया, दिस फॉर्मूला इज गिवन इन योर आवर IS कोड 456. Right? So how this formula is derived? This is derived through the practical approach. On many samples, the professors from IITs have done the experiment, and through that experiment, they developed this particular formula. Okay. Now, please all of you tell me, for M20 and M30, what will be the value of EC? Please calculate and tell me. For M20, it is going to be 22360. For M30, it is going to be 27386 Newton per mm square, or MPa we can say. Absolutely correct. So this they can directly ask as an objective question. So all of you should remember this particular. Clear hai? Next property is we will see the stress strain curve for the concrete. Stress strain curve for the concrete. So IS code suggests this is my stress, this is my strain. The normal stress strain curve for concrete comes like this. Like this, generally through the experiment we get a curve like this. Okay, but our IS code suggests to use the curve like this. This is what our IS code suggests, to use the curve like this, so that we can uh, do the designs practically, and we can avoid the complex. In that, the important thing is here, this is the location where you are getting first yield, right? This is the location where you are getting the first yield. This yielding is defined as nothing but your compressive strength. This is your FCK value. This is your FCK value, and it occurs at a strain of 0.0020. And ISCO suggests that the concrete sample should fail, or the structure should fail, at a strain of 0.0035. 0.0035. At that strain, it should fail, and the grade and the compressive strength will remain same. So this is remaining constant through this. This is the stress strain curve suggested by our IS 456, right? Where FCK is your compressive strength of the concrete. Now, what happens, as all of you know, that concrete is heterogeneous. Heterogeneous material. Now, what do we mean by heterogeneous? There are two types of world. One is homogeneous, one is heterogeneous. Homogeneous is the one which is having properties same throughout, or which is made up of one material and it is showing the same material throughout. But concrete is not homogeneous. It is made up of your aggregate, your sand, your cement, right? So it depends on the properties of the aggregate. And then it depends upon the properties of cement as well. What quality of cement you are using? Are you using good quality of cement or not? Are you using good quality of water or not? Some people, what they will do, they will simply use the drain water also for making the concrete composition, right? So all these factors, all these variation in the quality, variation in the quality of the concrete, variation in the quality of concrete reduce for the variation in the quality of concrete, for the variation in the quality of concrete, IS code suggests to reduce the compressive strength of concrete of concrete by 0.67. By 0.67. That means we will reach here 0.67 FCK. And ISCO suggests you should use this much strength of concrete only. Because in actual you might be getting 20 MPa, but IS code is saying no, you don't use 20 MPa, you reduce it by 0.67, because we don't know in reality how much quality of material is being used by the people. That is why from the safety factor they are reducing the strength. So your strength of the concrete, compressive strength of concrete is equals to 0.67 FCK. Then further, the design strength the design strength of concrete is further reduced by a factor of safety. We further divide this particular by the factor of safety to get which strength? To get the design strength. To get the design strength. Now, what is this factor of safety for the concrete? This factor of safety for concrete is equals to 1.5. Is equals to 1.5. This we called as a material factor of safety. Material factor of safety. So our design concrete strength will going to be that is going to be 0.67 FCK divided by 1.5. So this is going to give you, I think, around 0.45 FCK. 0.45 FCK. क्लियर है? कोई डाउट इसमें किसी को? Now, this is your property number. This is the stress strain curve. Then the fourth property we have is your tensile strength of concrete, or we call this as a modulus of rupture. Tensile strength of concrete or the modulus of rupture. ISCO suggests that the modulus of rupture, we represent that by FCR. C is for concrete, R is for the rupture. FCR is equals to 0.7 times FCK. This is also an important formula. They can directly ask you in the objective, what is the modulus of rupture for the M20 grade of concrete or M25 grade of concrete. So let's say if I have M25 grade of concrete, the FCR is going to be 0.7 into square root of 25. So my FCR will become is equals to 0.7 into 5. So this is going to be 3.5 Newton per mm square. Clear है? कोई doubt इसमें? Modulus of rupture, directly you have to remember the tensile strength of the concrete, or the modulus of rupture of the concrete is nothing but 0.7 times square root of FCK. क्लियर है सबको, कोई डाउट इसमें? चलो, if this is clear, then next we have is your, these are the properties of concrete. The next we will see is the properties of steel or reinforcement. Properties of steel, or we say the properties of your reinforcement. Now, again, in the reinforcement, the first thing, what are the properties we have seen? Those properties we will see in the जो concrete में देखा था वो steel में भी देखेंगे. Number one, grade of steel. So in the steel, we have three grades: Fe 250, Fe 415, Fe 500. These are the three grades of the steel we use. Now, what is the meaning of these grades here? Nothing but Fe is nothing. Fe we use for your iron, right? 250 represent the yield strength of this grade. That means the yield strength for steel Fy is equals to 250 Newton per mm square. 415, the yield strength is going to be 415 Newton per mm square, and then 500 means Fe is Fi is 500 Newton per mm square. This particular grade is called as a mild steel. Fe 250 को हम mild steel भी बोलते हैं. And this particular grade is called as HYSD bars, high yield strength deformable bars. High yielded strength deformable bars. In the market, you may see now as we are progressing, we are getting very good steel also. So you may see the grade of concrete as Fe 550, 550D also. You might have seen on the different reinforcement. अगर आपने कभी साइट पे कोई सरिया देखा होगा तो उसके ऊपर ये मार्क लगा रहता है. The mark will be mentioned on that particular bar, Fe 550, Fe 500, right? That mark is representing the yield strength of that particular bar. Okay, so 500 means the yield strength will be 550 Newton per mm square. But these three are our basic bars. Okay, as we will progress, we may see 550, 650, 750 like that in the future also. But these are the three basics which you have to remember. Sarthak, we use Fe 250 in case where we want less strength but more what we call deformation. I will tell you where generally we use when I'll make the stress strain curve for the steel. Okay. Now, see here, sometimes this particular word D becomes important. Okay, they can ask you an objective. In Fe 550D, what is the meaning of D? Or in Fe 500D, what is the meaning of D? Here, this D represent your ductility. D represent your ductility or the ductile state. Now, the question comes, what is ductility? So, we have two types of material. One is your brittle material and one is your ductile material. I'll tell you others. What is the difference between the ductile and the brittle material? See, from the name itself, it is suggesting. Brittle means it will fail easily. It will fail. It is a kind of a brittle thing. So if something fail much more easily than the ductile material. So what happens if I draw a stress strain curve? So I will get a brittle material stress strain curve like this. Whereas for the ductile material, I will get a stress strain curve like this. That means what is happening in case of the brittle material, this is my stress strain curve. For ductile material, this is my stress strain curve. The brittle material is not having much elongation. Not much elongation. Whereas your ductile material is having much elongation. Very good elongation. Elongation is nothing but your, if we write strain is equals to change in the length divided by the original length. That change in the length is nothing but your elongation, right? So brittle material will not have much elongation. That means they will fail at lesser stretch. They will fail at lesser stretch. Whereas the ductile material is having good elongation, means we can stretch them very much before the failure. So your concrete alone is a brittle material. Concrete alone is your brittle material. But when we add reinforcement along that, then it will becomes a ductile material. Then it will become a ductile material. So now, why ductility is important? Because let's say if you are making a building, okay, this is your building. In this building, let's say due to the wind or due to the earthquake or due to the dead load or due to the live load, let's say your structure is getting failed. If I'm applying more force, let's say your structure is getting failed. Now, in case of brittle material, what will happen? You will see the sudden collapse. You will see the sudden collapse in case of the brittle material because it is not getting stretched. जैसे ही इसके ऊपर लोड लगा ये यहाँ पे फेल हो गया. But in case of your ductile material, there will be no sudden collapse. No sudden collapse. It will give warnings before failure. It will give warning before failure. It will give no warning. How it will give warning? Because this particular material, if it is breaking, it will break with elongation. That means some portion will chip off and it will come out like that. Some portion will chip off from here and it will come out. That means it is getting stretched with the applied force. That is why ductility is very, very important in the structure. A structure has to be more ductile than a brittle so that we will get a sufficient warning before failure, and the people who are residing inside the house, they can leave the house before getting that particular structure failed. Right? समझ में आया difference between ductile and brittle material? Is it clear what is the difference between ductile and brittle material? Right? Now here further we will see is the stress strain curve for steel. So the stress strain curve for steel looks like this. जो हमने स्ट्रक्चर एनालिसिस के फर्स्ट क्लास में देखा था, that's the same curve, right? This is for, now here I will make the stress strain curve for all the three grades. So this is for Fe 250. Then we have next one is your this is for Fe 500 415. This is for Fe 250. This is for Fe 415. And further we have this is for your Fe 500. Like this, right? So here, this is my Fy is equals to 250 Newton per mm square. Here, this is 415 Newton per mm square. And here we have your 500 Newton per mm square. Now, by looking at this structure, by looking at this stress strain curve, can you tell me which grade of the concrete is having more ductility? Fe 250. Fe 250 is more ductile than your Fe 415 and Fe 500. It is more ductile than Fe 415 and 500. That is the reason, Sarthak, we use Fe 250 in the places where the risk of earthquake is more and less strength is needed. Less strength is needed. So what will happen with those structure? Let's say you are making one ground floor or G+1 story building. Then you don't need much high strength of the steel. In that case, you will provide Fe 250 For example, you see in our northern Himalayas, or like in the Himalayas region, northern part of our country, there we will see many earthquakes coming very frequently, right? So there we should use your Fe250 grade of the concrete when the strength is not much required, but the ductility is very important. Why ductility is very important? Because in case of earthquake, the reversible of stresses may happen. A risk of reversible stresses means we don't know if this is my structure. We don't know that the earthquake may be applied from this direction or it may be applied from this direction. So if you have designed one of your structure from this direction for the compression, that may act as a tension from the different direction. That is why in that case we need a more ductile material. We need a more ductile material. Also, 250 is cheaper than these two grades. So cost wise also we can trade off. Clear hai? Chalo, perfect. Now here I told you that the slope of this curve, this slope of stress strain curve will give us what? Slope of stress strain curve will give us what? Modulus of elasticity. Modulus of elasticity. The modulus of elasticity for steel for all the grades is 2 into 10 to the power 5 MPa, Newton per mm square. This is directly fixed and you can expect a question directly on this. Clear hai? Now, based on our stress strain curve, let's say I am taking a stress strain curve for any one grade. So this is my stress strain curve for, let's say, Fe250. For this grade, we got, this is our Fy. So the yield strength of steel, if you see yield strength or you see directly the strength of the steel, that means he's talking about the yield strength of steel. So yield strength or strength of the steel is equals to Fy. We represent this by Fy. And the design strength of steel is going to be Fy divided by factor of safety. Now you can see here, IS code is not reducing this Fy by 0.67 as we did in case of concrete. Why? Because steel is homogeneous material. Steel is manufactured in the factories, whereas the concrete is manufactured at the site itself only, or sometimes we transport from some place to the other place, right? But steel is always manufactured in the factories. There we can have a control precision over its strength, or we can have the precision control over its what we call its particles or its composition. That is why there will be very less variation in its strength. So IS code is suggesting we will not reduce its strength. Only when we are designing, that time we will divide this by the factor of safety. Now, what is the factor of safety for the steel we use? Factor of safety for steel is 1.15. Now again, this can be an objective question for you. Why the factor of safety for concrete is higher than the factor of safety for steel? Please tell me why the factor of safety for concrete is higher than for the steel. FOS for concrete is 1.5. Why it is more and why it is less for the steel? The one answer is steel is homogeneous and concrete is heterogeneous. No, Dheeraj, steel is having more strength. Strength is a different thing. We are comparing the constitutes where we can have the uniformity. Not more important member of our system. No, important होता तो फिर इसकी फैक्टर ऑफ सेफ्टी और ज्यादा रखते. For example, if I compare Adarsh and Dheeraj, right? On what basis I will compare both of you? I have never seen your faces, right? I don't know you personally. I will compare both of you based on your ability of performance, right? Absolutely. How you are performing in the site. Quality, absolutely. That is why the quality we achieve in the concrete is lesser. Quality is less. Whereas quality is more here. If the quality is more, that means I need not to be worried. Where the quality is less here, I have to be worried. That is why I have to increase its factor of safety. Clear? Now, if I'm increasing my factor of safety for the concrete, for the steel to 1.15, then what will be my design strength? So my design strength is going to be Fy divided by 1.15. That is going to be around 0.87 Fy. That is going to be 0.87 Fy. Yeah, round figure कर लो 0.87 Fy हो जाएगा. Clear? Right? So these are the properties of concrete and steel. These are the basic properties which you should know before we start the designing. Any doubt in these properties till now? Please tell me if you have any doubt in these properties. Clear hai? Perfect. If no doubt, then further we will go onto the design methods. What are the methods through which we design our reinforced concrete structures? लिख लिया रितु? चलो एक काम करो. Let us take a break of 10 minutes. We'll start after the 10 minutes and we'll do the design methods. Okay, we'll be back at 8:37. एक 10 मिनट का ब्रेक ले लो. We'll start at 8:37. Okay, so let us start. So now we will going to discuss about the design methods. So we have we have two design methods, specifically two design methods for designing of our reinforced concrete structure. The first one is called as WSM, that is working stress method. Working stress method. See, your reinforced concrete structure or the design of reinforced concrete structure, it is based on the what we call it is based on the experiments. It is not a directly like a mathematical concept. If we are getting some formula, based on that formula, we will do this, we will do that. No, it is based on the research and analysis. And the research and analysis is progressive. As we do more research, we get more data and we implement several different kind of methods. Similar to that, earlier we used to design our all the structure using the working stress method. So earlier we had our IS 456 1987. So in the year 1987, we developed the code for designing the reinforced concrete structures. That code, 87 wala code, is used to be based on the working stress method. But nowadays we are using LSM, that is limit state method. Limit state method. That method is based on your IS 456 2000. That means this particular code was designed or developed in the year 2000. So 2000 से अभी तक till 2024 we are using our LSM, limit state method, and based on the limit state method only we are designing our structures. Earlier we used to design through this method. Now what are the discrepancies which was there in this method, so that we had to leave this method and we have to go on this method? That is important for us. But now further, whatever we will see, those everything will be based on the limit state method, because this method is only in our syllabus. Now this is all dated, we are not using it. Now, why do we have to leave this particular method? See, working stress method, WSM, was based on working stress method was based on the linear elastic concept. It is, or it was, based on the concept of fixed factor of safety for the design. These are the two major disadvantages of this particular method. See, what we used to do in the WSM, that in WSM, this is my stress strain curve for steel. Let's say this is my stress strain curve. We will use this stress strain curve only till the elastic limit, linearly elastic limit. That means till the limit where sigma is proportional to E. Till that portion only we will going to use this particular material. Same with the concrete. Whereas if you have seen right now, the concrete is having a non-linear curve like this, right? But what we did in WSM, we used to make this as a linearly elastic like this, and we used to find out the and we used to do the design, which is not correct, because if we do this, then the modulus of elasticity will reduce. So these were this one was the first discrepancy of this method. That is why we had to leave this method. The second major discrepancy of this method was it was on the concept of fixed factor of safety. That means uh, some researcher have given some factor of safety of, let's say, 2 for concrete or 3 for steel, like that. The fixed factor of safety we have taken and we have designed it. And that factor of safety was uh, uh, that was like moving throughout the years and years. We did not think about it. But that is also not correct, because the factor of safety should be defined based on the material, based on the loadings, based on the people's working condition, based on the quality of the work. All those things were not taken in the WSM. That is why we had to leave this method and we moved to the method that is called as your LSM, limit state method. In the limit state method, we use the concept of non-linearity. Non-linearity concept is used in the limit state method. And in the limit state method, we defined partial factors of safety for both materials and loads. Both materials and loads. Meaning of this, here, this limit state, the word limit state, this is an important thing. This can be an objective question for you. What is the meaning of limit state in the limit state method? So this word limit state refers to a state of impending failure. That is if a structure is loaded beyond the limit state, then it will not perform its intended function. That means what we are doing in limit state, we are designing our structure to the point where the material should fail. For example, what we used to do in the WSM, let's say my structure capacity is 100 kilonewton. What we used to do? We used to simply divide this by a factor of safety of 2, and we have taken a 50 kilonewton design load on that, and we used to go ahead with that. That means we are not utilizing its full capacity. We are just leaving 50 kilonewton behind only. We are only using 50 kilonewton. Whereas in limit state, what we are doing, we are making sure that if its capacity is 100 kilonewton, we are reducing this capacity based on the factors only. What are the factors? Factors could be your material discrepancy at the site, the quality and the workmanship at the site. Based on that, we will reduce this to, let's say, 70 kilonewton or 80 kilonewton, which is a practical thing. That in the site, your workmanship may be different. Somewhere you may get some good quality of labors, but somewhere you will not get, which is the case in our most of the rural India, right? So that workmanship is defined in the limit state. And based on that, only all the safeties are taken. And then it is stated, if you are exceeding this capacity, your structure will definitely going to fail, even if it is having a capacity of 100 kilonewton, right? That is the difference between the limit state and the working stress method. Now, we will going to study only our limit state method. We will going to study only the limit state method because that is only in our syllabus. Clear है? कोई doubt इसमें किसी को? Please tell me if you have any doubt. Clear? Okay. Further we will move that our limit state method, LSM, is divided into two parts. One is your limit state of collapse, and another one is your limit state of serviceability. Limit state of collapse and limit state of serviceability. Now, what is the meaning of limit state of collapse? Nothing but this is the limit to satisfy this limit state. To satisfy this limit state, the strength must be adequate. The strength must be adequate to carry the loads. Meaning of this, when you are designing for the collapse किसकी वजह से होगा? Loads की वजह से होगा, right? So you have to design your structure for carrying the loads so that your strength satisfy the materials design strength, and your the loads which is coming on the structure are within that design strength. That is called as a limit state of collapse, that we are designing before the collapse of the structure. Whereas your serviceability is, as the name suggests, it is for the service. Means during the structure's lifespan, let's say if it is 20 years, 30 years, 40 years, during that time, how your structure is giving the service to you, that will come under the limit state of serviceability. So in this we will write to satisfy this limit, comma, deflection, cracks, etc. must not be excessive. Meaning of this, during the service of your structure, are you seeing any crack in the building? Because of the crack, your structure will not collapse immediately, but those cracks will lead to the progress that sometime it may lead to the collapse. But if you repair those cracks within your service time, then you will be safe. So that is why we study the limit state of serviceability. During the service, what is the maintenance we have to give to the structure, that we study under the limit state of serviceability. But to design that structure, how much load it should have the adequate capacity, that we study under the limit state of collapse. So under the limit state of collapse, we will going to study the limit state of collapse, limit state of collapse due to number one is your flexor. Flexor is nothing but that is your bending moment. बेंडिंग मोमेंट की वजह से क्या क्या लोड्स आएंगे, उन लोड्स के लिए हमें इसको डिजाइन करना पड़ेगा. We will have to design our structure due to the loads coming on it, due to the bending, whatever the loads are coming on it. For that we will have to design. Number two, we will have to design the limit state of collapse due to the shear force. Due to the shear force, we have to design our structure. Number three is your compression. Due to the compressive force, what are the failures we can expect? All those loading condition will come under the compression, right? Then we have the fourth one is your, like bending moment, we have the torsion also. So we will design our structure for torsion also. So the torsion is like, these are the these are the major loads which we see in our structure, right? Similarly, what are the major types of limit state of serviceability that we will see? So we will have your deflection. We will have your cracks or cracking. Then we will have your corrosion, right? You might have seen the rusting of the reinforcement, jung lagna, right? All those things we will see under the maintenance, under the serviceability, right? Then you will see the vibrations, right? So these are the main four major categories under your limit state of collapse and under your limit state of serviceability. These are your direct objective question. They can ask like this. Designing a structure for deflection comes under limit state of collapse, limit state of serviceability, both, or last option, none. So your answer should be, it should come under the limit state of serviceability. Clear है? कोई डाउट इसमें किसी को? धीरज बोल रहा है सर, cost of WSM will be more, right? And WSM will be more safe as compared to the LSM for occupants. No, Dheeraj. The cost in WSM may be more because it is using more capacity. But WSM is not safe. अगर safe होता तो हम LSM में क्यों जाते? WSM is just taking the factor of safety. He is not considering the fact that how the workmanship is there in the site. It is not considering the fact of how the loads will going to behave in the site. For example, we will see right now in limit state that if, let's say, on my structure a load is coming as 100 kilonewton, okay? If a load in my structure is coming as 100 kilonewton, then in LSM, we will design this for 150 kilonewton. कि भैया नहीं 100 किलोन्यूटन नहीं, तुम 150 के लिए डिजाइन करो. Whereas WSM क्या कहता है? You design this for 100 only, but you divide this later on when you are considering the material safety. In the material safety, you divide this by let's say factor of safety of 2. Whatever the material safety you have, let's say for concrete, you have 20 MPa, so you divide this by 2. But what LSM is suggesting, you use this as 150, and then for material also, you divide this by 1.5. Here, he is not increasing the load. We are increasing the load in LSM. So we are taking safety from both sides, from the load side also and from the material side also. That we will see now itself only. How the material factor of safeties and the load factor of safeties are defined. क्लियर है? और किसी को कोई डाउट? Okay, if this is clear, then further we will write the factor of or the partial factor of safety in partial factor of safety in LSM. So partial factor of safety in LSM is defined for, one is for materials and one is defined for loads. One is defined for your materials and one is defined for your loads. So your design strength is going to be, design strength is going to be your strength divided by partial factor of safety of materials, that we represent by gamma m. M is for materials. So this is going to be your strength divided by gamma m. That is the design strength of materials. Okay, design strength of materials. Whereas the design load is going to be the load multiplied by factor of safety for loads. This we represent by gamma F. F is for the loads. So this is going to be load multiplied by gamma F. Now, as we have already discussed that your gamma m is equals to 1.5 and is equals to 1.15. This is for concrete and this is for your steel. So what we are doing, if my material is, let's say, grade of concrete is M20, its compressive strength is 20 Newton per mm square, I will reduce this by dividing 1.5. So I am reducing its actual strength. Actual में 20 है, लेकिन मैं उससे कम ही use करूँगा. That means we are on the safer side. But what we are doing in case of the load, is that if this is my structure, on this, if I'm getting, let's say, 100 kilonewton load, what I will do, I will multiply this by 1.5. I will consider this as 150 kilonewton and then I will design my structure. आपने सब कुछ मान लिया कि भैया उस पे 100 से ज्यादा नहीं आ रहा है, लेकिन आईएएस कोड कहता है नहीं, जहां पे आपकी सोच खत्म होती है वहां पे मेरी सोच शुरू होती है. आप उस लोड को 1.5 से और इंक्रीज करो. Right? So that is why what we are doing in the limit state concept, we are increasing the loads and we are reducing the strength so that we will have more safety from all the point of view. And hence we will have more safety from all point of views. That is why you might have seen that there are many buildings in India. You might have seen, if you leave the earthquake or the winds, because those are the natural phenomena. If you see any building which is filled by dead load and live load, hardly you will see the buildings will be filled by dead load and live load if it is properly designed as per the IS code. Because in that we are giving a huge factor of safeties, right? So that is the difference between the design strength of materials and the design strength of loads. Now, design strength of materials, for that we have seen the factor of safety. Now we will see what is the factor of safety we have. What is the factor of safety we have for the loads? So the second point we have is gamma F, factor of safety for the loads. Now, IS code suggests that, first of all, what are the loads we have? We have dead load, we have live load, we have your wind load, and we have your earthquake load, which can be there on our structure. खुशहाल कह रहा है बिहार में ब्रिजेस तो गिर जाते हैं. That is related to corruption, Kushal. Those people are totally corrupt. That is why it गिर जाते हैं. मुंबई में तो क्यों नहीं गिरते हैं? मुंबई का अभी देखो, that sea link which is created, that's a fantastic, right? अटल सेतु, yes. वो कोलैप्स क्यों नहीं हुआ? Because they are using that much quality, they are giving importance to the material safety. Bihar mein, they are not doing that. The huge corruption is there in Bihar, right? खड़ा होने से पहले ही ब्रिज गिर जाता है यार. So that is not related to the design. That is not related to a design engineer, right? That is totally related to the low quality of material they are using, and they are not even following the standard practice. Correct? Now, please tell me if you know any other major load other than these four. Dead load, live load, wind load, earthquake load. इसके अलावा और कोई major load? Water means tsunamis we can have, right? Tsunamis we can have, or flooding we can have, right? Generally, the areas where we can have the tsunamis or we can have the more flooding, those areas are designed as a spatial structures. So we will not see those loads here. Majorly, we have only these four loads, right? Now, all of you know what is dead load. I believe I need not to explain what is the dead load. Dead load is nothing but due to the self weight of the structure. Due to the self weight of the structure, right? Live load also, you know, the load which is not fixed, which can be movable from here and there. Like the people are sitting in the room. You are the live loads. You are not fixed. Like your furnitures. If you can move your furniture, you are not fixing them permanently. They are the live loads, right? So those are the example of live load. And similarly, we have the wind load and we have the earthquake load. That is self-explanatory. Now, for all these loads, we have our IS code. So, जो मैंने पहले बताया था, that is used here. IS 875 is used for the loads. IS 875 part 1 is for the dead load. IS 875 part 2 is for the live load, and IS 875 part 3 is for the wind load. These parts, I mean, these IS codes will tell you how much live load you should consider during the design. For example, when we are designing a room, let's say it is a residential complex. For that, how much live load should we consider? So we have to go and we have to see how much load is given in the IS 875 part. Generally, it will be around 3 kilonewton per meter square if it is a residential building. And if it is a commercial building where the movement of people is more, it may reach to 5 kilonewton per meter square. Right? So they'll not ask you what is the value of live load in the assembly building or in the schools or in the residential buildings. But they can ask you that the live load is defined under which IS code. So that is under IS 875 part 2. Right? Similarly, the earthquake load is, for the earthquake, we have a separate IS code. What is that IS code? We will discuss that separately when we will see the something related to the earthquake design. Right? Now, for all these loads, IS code is defining your factor of safety for the loads. What is that factor of safety? See, generally, we will going to use the load combinations. What are those load combinations? These load combinations are, we know if I'm designing my building, on my building, definitely I will going to have the dead load. Dead load is the fixed. Because if the building is there, if a structure is there, it will have its self weight. Now with the dead load, we can have the live load. भैया बिल्डिंग किसके लिए बना रहे हो? कोई उसके अंदर रहेगा, कुछ फर्नीचर लगाओगे, that is your live load. So dead load and live load will be generally together we will have, right? Then the second load combination which we can have is dead load plus your wind load oblique your earthquake load. Meaning of that कि let's say कि आपका कहीं पे भूकंप आ जाता है, you get the earthquake. So during the earthquake, what will happen? You will try to escape from the building. So in that case, only the dead weight of the structure will be there, and the earthquake, whatever the forces are coming through the earthquake, that will be present. But in some cases, it may so happen that you are not able to escape from the building, then your live load is also present and your earthquake load is also present. Right? Then we have to use all three these load combinations. Right? Now you might be asking, sir, आपने ऐसे क्यों लिखा wind oblique earthquake? Because wind and earthquake both together cannot happen. That if it will happen, it will be rare to rarest. Till now, it has not happened. During earthquake, you will not see a huge storm coming. Or during the huge storm, you will not see that a major earthquake is happening. That is why if we design like this, dead load plus live load plus wind load plus earthquake load, then it will be a very huge quantity. And that much actually would not be required. As soon as we are increasing the load, what we are doing? We are increasing the cost of the structure. That is why practically it has been, these load combination are developed in a such a way that these can impact the stability of my structure. Due to these combination only, my structure may collapse. Now, for these load combinations, the load factors are given as load factors we have. So first load factor that we will take, that is for your dead load, and then we have for live load, then we have for your wind load oblique earthquake load. So for the dead load, this is we are seeing for limit state of collapse. This is for limit state of collapse. So for the dead load, the factor of safety we consider as 1.5. And for the live load also, we consider 1.5. Now here, the combination is for dead and live only, so this will not come into picture. Here again for dead load we consider 1.5, live load is not coming into picture, and for earthquake and wind load also we consider 1.5 for this particular load combination. But when all three are acting together, then we reduce this load factor little bit, and for all three we consider as 1.2, 1.2, 1.2. Right? So these are the load combinations we use for the limit state of collapse. Whereas for the limit state of serviceability, for limit state of serviceability, so here we have limit state for service. For that, we only use the load factor as 1, 1 dash, 1 dash 1 and 1, 1, 1. Because in the service time, we need not to increase for the more load. Because the deflection, the cracks, the vibration, those will automatically going to happen because of the collapse. So when we are designing the collapse itself only for the huge quantity, then there is no requirement to design it for the service with a huge load factors. So mostly we will take the load factors for our limit state of collapse. For our limit state of collapse. Now, how we will use these load factors? Very simple. And this concept is being asked in your exam many times. So this concept is very important. Okay. 5-6 इसमें numerical questions पूछे गए. So this concept is very, very important. Now, here, let's say I'll give you an example and you have to tell me, let's say my dead load is 100 kilonewton, my live load is 50 kilonewton, and my earthquake load, or let's say my wind load is 200 kilonewton. Then what is the design load for limit state of collapse? Please do it and tell me what will be the, based on this table, please do it and tell me what will be the design load. धीरज, कहीं जाना है? इतनी जल्दबाजी क्यों कर रहे हो? Check it properly and then give me the answer. Don't do hurry. Check all three load combinations and give me answer. Dheeraj and Kushal. I always prefer accuracy over speed. The people who give me accurate answer, they are more preferred over the people who are giving me the answer with the speed. Because speed will give me minus negative marking, but accuracy will give me the positive marks. Take your time and apply all three load combinations and then give me your answer. 420 is wrong answer. Answer. 450 is the correct answer. हाँ, तो कुशाल किस चीज की जल्दी थी पहले? प्लीज टेल मी, किस चीज की जल्दी थी पहले? Over smartness. Over smartness will lead you to out of 100 rank, right? Speed matters, but speed matters when the accuracy is correct, right? Chalo. All of you please see, I'll explain. All of you please see, I'll explain. See, these are the loads is given to us. It is being asked to find out the design. What is design load? Design load is equals to the load factor or the factor of safety multiplied by the loads, right? And whatever the maximum out of it, that we have to take, because for the maximum only we're going to design, right? So what is your first load combination? Your first load combination is dead load plus live load. So dead load plus live load, both are having a factor of safety of 1.5. So 100 into 1.5 plus 50 into 1.5. That is my first load combination. Second load combination I have is my dead load plus wind load. So that is also 1.5. So 100 into 1.5 plus 200 into 1.5. Then the third load combination we have is dead load plus live load plus wind load. So this is going to be 100 into 1.2 plus 50 into 1.2 plus 200 into 1.2. Right? Now, please solve all three and tell me what is the value. Dheeraj, you will only tell me. क्या आ रहा है तीनों का आंसर? What is the answer for all three? Dheeraj. No, no. 1, 2, 3 का आंसर बताओ. First one is how much? 225 kilonewton. Second one is how much? 450 kilonewton. And third one is your 420 kilonewton. Right? What is the maximum out of it? So the maximum is 450 kilonewton. That is our design load. Right? So we used to write our P. These are given as P. P are given here. So what is my PD? D is for design. So PD is 450 kilonewton, right? Point load को P से लिखते थे. So PD is going to be 450 kilonewton. Clear है? कोई doubt किसको इसमें? So even if we have all three, we need to take the highest value among the three combination and consider that as yes, Kavya. Yes, you have to take the maximum because we have to design our structure for the maximum case only. Because this is a possible scenario in real life, right? आप अपने घर के अंदर बैठे हुए हो, आपके घर का डेड लोड लग रहा है, आप उसके अंदर बैठे हुए हो तो आपका लाइव लोड लग रहा है, और बाहर बहुत तेज आंधी तूफान आ गया तो विंड लोड भी लग रहा है. That means you have to design for all three load combinations. Clear? All of you, is it clear? Yes. Now, see, in your exam, in your GATE exam, what they will do, they will give you the questions like this. They'll give you the questions like this. For, let's say, for a beam, the dead load is 100 kilonewton and live load is 150 kilonewton, full stop. The factor of safety for dead load is 1.2 and for live load is 1.7. What load should be used for the design? for design. Now, if they are giving you the factor of safeties in your exam itself only, then you don't have to use the above table which I told you. Okay, and in 99% cases, they will give you the factor of safeties. If they are not giving, then only you have to use these factor of safeties, okay, which I told you here. 99% cases में वो आपको ये टेबल दे देंगे, वो आपको ये टेबल दे देंगे. If they are not giving, then once you go through this, okay, they'll give you the factor of safeties in your question itself only. So you need not to remember extra those tables. Okay. Now please tell me what will be your design load here. Just give me a second, guys. Yes. So is this clear to all of you? The design load is going to be 1.2 times 100 kilonewton plus 1.7 times your 150 kilonewton, right? If you solve this, you will going to get 375 kilonewton as your answer, right? Just give me a second. Okay, so further after this concept, now we will see, now we have to go through each and every limit state. Okay, so in the next class, we will start with our limit state of collapse for flexure. Limit state of collapse for flexure. Flexure means for your bending moment. So with this, we will start and we will cover all the limit states. Limit state for then we will see for shear, then we will see for your torsion and for your compression. Whatever the useful limit states we have, we will see all those and we will solve the previous year questions also. Right? तो आज क्लास को यही क्लोज करते हैं. आपको किसी को कोई डाउट है तो you can please type your doubts. I will take your doubts. Else you can leave. Thank you. If you have any doubt related to structures or to today's class, you can ask. Sir, how do we calculate the wind load as it's keep varying? Sarthak, for that you have IS 875. In that IS 875, if you'll see, for all our states in India, we have defined a basic wind speed. So, for example, from which state you are, Sarthak, or which city specifically? Madhya Pradesh. City, Rewa is a, let's say, it's not that much known city, but if you take the Indore is having a wind speed of roughly around 40 meter per second. The maximum wind speed you will see in the coastal area around 50 meter per second. So these are the basic wind speed given in our IS code. For it is defined for all the states, all the major cities. So with that reference, we will take to the smaller cities which is nearest to that. For this basic wind speed, then we will multiply with many factors like your topography, how much, like if you are living in a mountainous range, for that we will have some factor. Then we will apply the factor for the gradients also. Somewhere we have the flat surface, but the gradient will be very high. Based on these factors, then we will calculate design wind speed. So some design wind speed we will get. For example, if you're getting 60 meter per second, then this design wind speed will give you the design pressure as 0.6 into V design square. This design pressure will be in your kilonewton per meter square. Now, based on your height of the building, you will multiply this with the height and you will get the UDL value. And based on that, we will design. Like this, we take the wind load into we calculate the wind load like this, right? But this is totally related to the civil engineering or the designers. They'll never going to ask you. But since you told so, I told you कि कैसे इसको निकालते हैं. हाँ, any other doubt? Suchi, I have a doubt in SFT BMD. Suchi, please send me on the WhatsApp. Whatever the doubt you have, I have given my WhatsApp number, right? You send me on WhatsApp. I'll discuss and I will tell you. Thank you, Adarsh. Anyone else? Any other doubt? Yeah, thank you, Suchi. Chalo. Any other people? Any doubt? Okay, thank you guys. Then we'll close the class here only. Thank you. Okay. So good evening to all of you. In the last class, we started with the design of reinforced concrete structures. In that, we covered the properties of the concrete and steel, and then we started basic with the our limit state method. So in the limit state method, we were discussing limit state. Under that, we had a limit state of collapse and limit state of service, or we call that as serviceability. So under the limit state of collapse, the first limit state that we will going to discuss today, that is limit state of collapse for flexure. Limit state of collapse for flexure. So with this, we will start our topic. Okay. So as you are aware, flexure is nothing the bending moment. So we have to design our beam for the bending moment. So as I was telling you in the last class, see, what do we do? From the structure analysis, we get the bending moment. For example, if this is my simply supported beam and this is subjected to, let's say, a 5 kilonewton per meter load over a span of 10 meters, right? So for this span, all of you know that we will going to get a bending moment diagram like this with the ordinate of WL square by 8, and this is positive, right? Now, if I put the value here, so this is going to be, how much this will come? 500 divided by 8. So that will be around 62.5 kilonewton meter. Correct. Now, this is the bending moment for which I have to design my beam. I have to design my beam. Now, designing means what? Designing means what? Designing means you have to design the width of the beam, the height of the beam or the depth of the beam, and the reinforcement in the beam. That is the meaning of design. So first we study the structure analysis so that we get how much amount of load is coming on our structure. So that load, that bending moment, we got it from the structure analysis. Now for this bending moment, I will design my beam like this. This is the width of my beam. This is the height of my beam. And since this is my sagging bending moment, and I know the compression will be on the top and tension will be on the bottom. So in the bottom, I will going to provide the reinforcement like this. So I have to find out the value of this reinforcement. Or this we call as area of steel, AS. This is the meaning of the design. This is the meaning of the design. Likewise, for such bending moment, we will design our columns, we will design our slab, we will design our footing, right? The major parts in our structure is, the major part for the building is your beam, column, slab and footing. Slab and footing. These are the major 4 components for the building. For these major 4 components, we have to design everything. We have to design the dimensions and we have to design for their reinforcement amount. Right? Now, as an architect, what the gate is expected from you? They will never going to ask you the design question, because design is not your part, or design is not your cup of tea, or design is not in your syllabus, because that is the part of civil engineering. Civil engineers do the designing thing. But what architects do, what architects should know, they should know some of the basic of the design. What is the basic in that? For example, let's say you are planning for a, let's say some uh, 50 feet by 30 feet one building you are planning. Okay, let's say this is 50 feet and this is 30 feet, some building you are planning. Now, as an architect, it is not your responsibility to design it, but you guys, what you will do, you will put the columns where you should put the columns. So you will put somewhere, let's say one column you will put on the each corners like this. Now, where else you should put? You should put the columns here, or you should put the columns here. That is the thing you have to learn in this. So you have to learn the basic. How much should be the width of my beam? For example, if you are giving a wall here of 230 mm, 230 mm thick brick wall you are proposing, right? Then according to that brick wall, you should know what should be the beam I am providing between these two columns. What should be this beam size? What should be the minimum depth of minimum width of that beam so that the configuration look clear, right? So they in the gate they're not gonna ask you to design this. They'll ask you the basic thing, right? For example, as in a designer or as in an architect, you should always know that if the length, let's say this length is 50 feet, right? Now for the 50 feet, how many columns should come here? 3 columns, 4 columns, 5 columns, how many columns we should provide? All those things you should know. Similarly, like this, they'll ask you some of the basic questions from the design. So we have to focus on the basic part only. We need not to go into the detailed designing because that is not in your syllabus, right? So we will going to start with basic things in each and every limit state, and we will restrict ourselves to the architectural things only. Clear hai? So now with the basic of limit state of flexor, we will start first with assumptions in the limit state of collapse. For flexor. What are the assumptions we take for the designing for the limit state of collapse? So first assumption you have is plane section should remain plane after the bending also. After the bending also. What this assumption tells? We studied this assumption in the when we were studying about our bending stresses, right? In the bending stresses, I told you, if this section is plane before bending, this should remain plane after the bending also. So if it is bending like this, so this section should remain plane after the bending also, right? It should not be curved. This particular thing gives us that the strain in concrete is linear. The strain in concrete is linear. See here, if your first section is like this, then after bending, it is remaining linear only. That tells the strain diagram of the concrete is linear. What do I mean by that? I mean, let's say if this is my beam, this is the width, this is the depth, and this is my neutral axis. This is going to be my strain diagram. Strain diagram. Or let's say here I'm providing my steel. Here I'm providing my steel. So that is the first basic assumption which we have already studied in the bending stresses. Then second assumption you have is maximum strain in concrete at top compression fiber should be or should not exceed 0.0035. 0.0035. That means here this strain should not exceed your 0.0035. That is the second assumption we have. And if you remember, we draw our concrete stress strain diagram like that only. So this was my concrete stress strain diagram. And from here, I told you this is the maximum strain we have in our concrete, that is 0.0035. And here we had 0.0020, right? So the maximum stresses in the concrete in compression. So if this is subjected to a sagging moment, so the top will be compression and the bottom will be in the tension. So in the top shed, it should not exceed more than 0.0035. These assumptions are very, very important. Okay. Direct objective question have been asked in the gate previously. So you should remember all these assumptions. Then the third assumption we have is maximum strain in the steel at the bottom should not exceed should not exceed this value. Now you will tell कि sir ये value कहाँ से आई? Very simple. You know that the strain in strain is nothing but the stress divided by the modulus of elasticity, right? Now what we are doing here, the strain in steel that is going to be equal to stress divided by modulus of elasticity. What is the stress? The maximum stresses in the steel we will going to get is your Fy. And this maximum stresses will divide by the factor of safety. We'll divide this by factor of safety. This is 1.15. Not 1.5. This is 1.15. So we'll divide this by the factor of safety. What is the factor of safety for steel? That is 1.15, right? And we will divide this by the modulus of elasticity of steel. So this is the strain the steel is getting. But at the location of steel, you will have concrete also, right? Here you will have the concrete also. So at the yielding, how much strain in concrete you are getting? Because that strain is already present. So this is the additional in that plus 0.0020. This is the concrete strain which is already there, plus whatever the strain you are getting in your steel, that is your Fy divided by factor of safety divided by modulus of elasticity. So this is going to be your maximum strain in the steel at the bottom, and this value should not exceed. So here, this value is going to be Fy divided by 1.15 ES plus 0.0020. That is going to be my strain in the steel. Clear है? अगर ये clear है, please tell me the maximum strain value for Fe 250, Fe 415, and Fe 500. What will be this maximum strain value? All of you please calculate and give me this maximum strain value. Yes. Anyone? Give me answer for all three. See, you know the Fy value, you know the modulus of elasticity for steel, that is 2 into 10 raised to the power 5. Factor of safety is also 1.15. Put everything and give me the value for 250, 415 and 500. So you just have to put like this, 250 divided by 1.15 into 2 into 10 raised to the power 5 plus 0.0020. How much this value is coming? Similarly, for the other part, give me the value for all three, all of you, please. And this was asked in your GATE exam. This was asked in your GATE exam. So this is very, very important. 2 marks question it was asked. Yes, please. I want all of you to answer. Point 00308, 0.0038 and 0.0041. Absolutely correct. So you just have to put all the values here and you will going to get your answer. So the first one we are getting as, so this is equals to 0.00308. The second one we are getting as 0.0038 and the last one is we are getting as 0.0041. Right? 417 something might be you are getting. Right? If you do 4-2 also, that is also acceptable. So no need not to be worried for that. Clear है सबको? इसमें कोई doubt? Yes guys, is it clear to all of you? आगे चलें. Perfect. If this is clear, then the fourth point you have is, the fourth assumption you have is all the tensile stresses, all the tensile or tensile stresses is taken by steel only. The tensile strength of concrete is zero. So IS code is telling to you that even if your concrete is having 2 MPa, 3 MPa, 4 MPa strength in the tension, don't consider it. Consider that as zero, that concrete cannot take any kind of tension. All the tension should be taken care by the steel. So this is how the code is developed, so that it is giving us the more safety. In actual, concrete may take some of the tensile stresses, but the IS code is telling no, you don't design for the tensile stresses. You just design the concrete for compressive stresses. You assume that concrete is having zero tensile strength, right? Now, what does this mean? If we see in our diagram, so let's say this is my beam, and this is, let's say, width, this is height and width. Here we are providing our tension. This is my neutral axis. This is my neutral axis. And this is the diagram I have for the strain. So this is my strain diagram. Now, for the stress, what IS code is telling? IS code is telling that only the compressive stresses concrete will take. That means this is going to be my stress diagram. Top I have the compression and bottom I have the tension, right? This is my compression and this is my tension. Now only in the compression you have to have the concrete stresses. In the bottom there will be no concrete stresses. So we here we closed it because below this there will be tension. So in tension there should be no stresses. Only the steel stresses should be there. That means here we will going to have our stresses in steel. So this is my tensile force, or I can say T, stresses in the steel. So this is going to be, if I write stresses in steel, so that is going to be, let's say, my Fs, stresses in the steel. Okay. Now, if you remember, we draw our diagram like this, stress strain curve. This is my stress strain curve, right? This is 0.0020 and this is 0.0035, right? Now, if you see here, this strain is your 0.0035, right? So what we are doing, we are starting from the maximum. So from maximum, we are going in a flat line. So here we have a flat line. So this is starting with 0.0035, then we have a flat line like this. So this point is your strain, here is your 0.0020. 0.0020. And after this strain, we are having a curve diagram like this. So this is my curve diagram like this. So from the strain diagram only, we are making the stress diagram. So this is my stress diagram. We're going to look like this. This is in the compression. And now here you see our steel is located at one position, right? The bars will be located at one position. That is why I have shown here a single arrow of the steel stresses, because there will be only stresses at a particular location. It will act as a point load in the axial direction. So that is why it is a point stresses there, right? Now, so this is your stress diagram. This is your stress diagram. This is your stress diagram. Now, IS code tells us, point number 5, IS code tells us that the compressive strength, the design compressive strength, or if I write here, this is, let's say, concrete, and this is my steel. So IS code tells that if the compressive strength in the concrete, compressive strength in concrete is equals to 0.67 FCK. 0.67 FCK. This we saw in the last class. Then the design strength is going to be, design strength in concrete is going to be 0.67 divided by 1.5. 0.67 FCK divided by 1.5. So that is going to be equals to your 0.45 FCK. That is the maximum strength our concrete can have, right? So that is why here we will going to get as 0.45 FCK. That is the maximum strength or the maximum stresses in my concrete. So this is going to be my 0.45 FCK. Similarly, in the steel, the tensile strength in the steel, tensile strength in steel is equals to Fy, right? So your design tensile strength will be how much? Design tensile strength is going to be Fy divided by 1.15. That is nothing but your 0.87 Fy. That is nothing but your 0.87 Fy. So here, this is going to be my 0.87 Fy. This is going to be my 0.87 Fy, right? This is how we get the stress and strain diagram for the analysis of reinforced concrete beams. क्लियर है? कोई डाउट इसमें किसी को? ये पांचों assumptions आपको याद रखने हैं. These are very important assumptions, and directly they can ask you question based on this. Dheeraj is saying, sir, is strain diagram why we are considering tension as negative? Not getting. It is your choice here. You consider tension as positive, compression as negative, or compression as negative, tension as positive. Positive, negative is just the symbols which we are putting. किसी एक को तो पॉजिटिव बनाना पड़ेगा ना. You can make this positive, this negative, up to you. See, concrete doesn't know what is positive, what is negative, right? Concrete पे जो stresses लगेगी वो लगेगी. So concrete doesn't know what is positive, what is negative. These negative, positive, sagging, hogging, all these are defined by the human, right? चलो. So shall we move ahead? कोई doubt किसी को इसमें? Yes, please. Is it clear to all of you? Perfect. Now, if this is clear, then further we will move to our beam analysis. Or the design of reinforced concrete beam, you can say. Design of reinforced concrete beam. Now, as we discussed the assumptions here, so based on the assumptions only, we will going to design our concrete beam. So if this is the diagram, we got it from the assumptions. This is my beam, and this is my stress, this is my strain, and this is my stress diagram. Like this I have. This is 0.45 FCK. This is 0.87 Fy. So this is the diagram I have. And here I have 0.0030, and this is, let's say, my 0.87 Fy by Es plus 0.0020. This is my width B, this is my height H, and this is my speed. Here I have the speed. Now, there's another term which will define here. This is my, let's say, neutral axis. Okay. Now, this is the steel we are putting somewhere here. Below the steel, we will going to have some cover. We will going to provide some cover, right? Why the cover is needed for the steel? Why the cover is needed for the steel? Cover means nothing. We'll just put concrete like 20 mm, 30 mm, 40 mm. Above that only we're going to put the steel. Absolutely correct. That is the protection from the weather. See, steel is very much corrodable material, right? So if you don't protect it from weather, if the steel is getting reacted with the water, what will happen? Corrosion in the steel will happen. So as the steel is getting corroded, it loses its strength. And hence, we have to protect our steel. We have to protect our steel. For that only, we are providing cover. So this is my cover, and this we call as the D. D is the depth of the beam, where your D is defined as D is equals to H minus cover. D is your H minus cover. Now, this is my neutral axis. This we defined as the depth of the neutral axis, XU. XU is the depth of neutral axis from top fiber. From the top fiber. So this remaining is going to be your D minus XU. The remaining is going to be your D minus XU. Right? Now, if you see this diagram, this is your stress diagram. Stress diagram. Now, from the stress diagram, tell me what will be the tension force? T. Tension force. Force is nothing but your stress into area. Stress into area. 0.00. This is 3.5. Sorry. Correct, Kushal. This is 3.5. Yes. 0.0035, not 3035. Thanks for correcting. Now, tension force. What should be the tension force? This tension force is the tensile stresses. How much it is there? 0.87 Fy. Multiply by the area of the steel. So let's say area of steel is your AS. Area of steel is your AS. Correct. Now, this is my tension force. Now, what is the area of steel? AS is nothing but AS is equals to area of steel. Meaning of that, if I say, let's say I have three numbers of 12 mm bar, 12 mm bar, 12 mm 5, then my area of steel is going to be 3 multiplied by pi by 4 into d square, that is 12 square. So if this is my steel, this is the saria or the reinforcement which you have seen in the side. This is a circle only, circular, right? If like this we are providing three numbers, so the total area is going to be 3 multiplied by pi by 4 into d square. This is how you have to calculate the area of steel. Now, if you know the area of steel, then you can easily calculate the tension force for a given grade of the steel, right? This is how you will calculate the tensile force. Similarly, the compressive force here, compressive force is equals to stress multiplied by the area. Stress multiplied by the area. Now, if you see here we have the stress in this diagram. This is my stress, right? And this is my XU. This is my XU. Now, here, if I make it a little bigger, so this is my compressive stress diagram. This is the XU value. And here I have 0.45 FCK. Right? This is my 0.45 FCK. Now I have to take the area of this. Right? If I take the area of this, then if I multiply that by XU into the width of the beam, then I will going to get my total compressive force. Right? So here the area is going to be my XU into B. XU into B. B is the width of the beam. Okay. Now what this stress? So this stress here we have 0.45 FCK. Then it is constant till here, and then it is reducing like this. So if we take the area of this stress, so the average stress which we are going to get, that is going to be your 0.36 FCK. Because it is not same throughout. It is not like this 0.45 entirely. If it had been the same, then we have taken 0.45 FCK. But if you take the area of this, there is a derivation of that. We are not going into derivation. So that is why I am directly writing the stress is 0.36 FCK. 0.36 FCK. So the compressive force C is going to be your 0.36 FCK multiplied by XU multiplied by B. XU is the distance from the neutral axis. Distance from the neutral axis from the top fiber. Right? Is it clear to all of you? ये C और T कैसे निकाला? कोई डाउट इसमें किसी को? Clear? Perfect. Now, if this is clear, then this particular, if I come back into this diagram, so here in this diagram, here, somewhere here, my compressive force is going to act. So this is my compressive force C, and this is my tensile force T. This is the tensile force T we will going to have if I make the force diagram, right? Now, this distance between compression force and the tension force, that is called as your lever arm. Lever arm. Okay, and this lever arm is nothing but, if this is my D, this is my D, then D minus this distance I have to do. D minus this distance I have to do to get my lever arm value. And this distance is nothing but, this is equals to 0.42 times XU. We have to calculate the CG of this compressive force. Since it is a non-linear, so we will have to take the area of parabola, then we have to take the area of rectangle, then we have to calculate the centroid of this. That is nothing but 0.42 times XU. So this lever arm, I call this as Z. This Z is nothing but, Z is going to be your D minus 0.42 XU. D minus 0.42 XU. That is my lever arm. Right? Now, once you got your lever arm, then you can easily define here the moment capacity. The moment capacity, or we call that as MOR, moment of resistance. Moment of resistance is nothing but, force into perpendicular distance. So if this is my force, T multiplied by, this is the perpendicular distance. So T into Z. I'm taking the moment between these two forces. So how the moment these two forces will create? These two forces will going to go like this. Like this, they will going to create the moment. Right? Now, this MOR could be T into Z, or this could be your MOR is equals to C into Z. From any force you can take. This is my moment of resistance. That much moment my beam can resist. That much moment my beam can resist. So if I write it down here, moment of resistance MOR is equals to T into Z or C into Z. दोनों में से कुछ भी हम ले सकते हैं. Then if I put the value of T and Z, so my MOR is going to, if I put the value of T, so T is 0.87 Fy into AS. And my Z is D minus 0.42 into XU. D minus 0.42 into XU. So from here, you will going to get your moment of resistance, or you can put as your C value also. Like this. This is going to be my moment of resistance. Now you can connect the dots. From the structure analysis, what we will do, from the structure analysis, we will get the value of MU coming on our structure, right? If this is my, let's say, simply supported beam, subjected to some 5 kilonewton per meter load, length is 10. For this, we got MU is equals to 62.5. Now, for this 62.5, what we will do? we will put mu is equals to moment of resistance. So here I am going to put 62.5 kilonewton meter. This is kilonewton meter is equals to my 0.87 Fy into As into D minus 0.42 into Xu. Now, from the dimensions of the beam that we will assume something, from those dimensions, we will going to get our D value and our XU value. Fy, the grade will be given to us what grade we are using. So based on all these three values, from here, from this formula, you can easily calculate the value of area of steel. Right? You can easily calculate the area of steel. So once you got the area of steel, that is the main thing for which we are designing our beams. This is the process through which we design our beams. Okay. Now here, you need not to remember all these formulas. You need not to remember all these formulas because they'll not ask you the design based questions. But you should know how the beams are getting designed. How the beams are getting designed. Clear है? कोई डाउट इसमें किसी को? Is it the same as m of flexure equation? M is the bending moment. M is your bending moment. Bending moment due to the loads. Yes, this is how you get the area of steel. So let's say from here, if you are getting, let's say my area of steel is 300 mm square. So from here, what you will do? You got 300 mm square. Now you can assume any dia of bar as per your choice. Let's say you are assuming 12 mm dia bar. Okay, then for 12 mm dia bar, what is the area? So area is pi by 4 into 12 square, right? So from here you can get the number of bars. So number of bars is going to be 300, that is the total area, and the area of one bar is pi by 4 divided by 12 square. From here you can get how many 12 diameter bars would be required for your beam. Clear, Adarsh? Chal. If this is clear, all of you, any other doubt you have? If you don't have a doubt, then please solve this question. Reinforcement area required to resist a bending moment of reinforcement area required to resist a bending moment of 100 kilonewton meter is 2000 mm square. 2000 mm square. Full stop. What is the number of bars required? What is the number of bars required? What is the number of bars required if provided that you can use 12 mm, 16 mm and 20 mm bars. 20 mm bars. Full stop. Beam is 300 mm in size. Beam is 300 mm in size and only and only 3 bars can be provided in one row. Only 3 bars can be provided in one row. And maximum 2 rows are permitted. Maximum 2 rows are permitted. Please solve this question. And this area you reduce to, let's say, 1600 mm square. 1600 mm square. Question को अच्छे से पढ़ो and then please try to answer the question. It is given to you that you have a beam of width 300 mm. This is the width 300 mm. And in this width, you can have only 1, 2, 3 bars. Not more than that you can have in one row. And maximum 2 rows means maximum you can provide 6 bars like this. So which bar you will going to provide? 12 mm, 16 mm, 20 mm, and how many you will going to provide? That is the answer. That is the question. What is the number of bars? Number of bars and the diameter. Number and diameter. Number and dia required. Grade of concrete not required. Ashpreet, AST already given है आपको. Area of steel is already given to you. Area of steel is already given to you. You just have to do number of bars is equals to 1600 mm square divided by pi by 4 into d square. Diameter of bar. Right? Now just put this, all the bar values you put 12 mm, 16 mm, 20 mm, and then see how many bars you are getting and which is suitable for your geometry. Yes, please. Twenty mm 5 bars. 20 mm 6 bars. Yes. Anyone else? Chalo, all of you please see here. All of you please see here. See, first number of bars. So you divide this for 12 mm. How much you are getting, please tell me. 12 mm के लिए कितना आ रहा है? Exact numbers you tell me. How much it is there in decimals, even if it is. Then for 20 mm you tell me. For 16 mm you tell me. And then for 20 mm you tell me. How much you are getting? For all three you tell me. Please tell me in decimals. You don't have to round off. I will tell you how to round it off, okay? This is coming as 14.15, 9.76 and 5.09. Correct? आ रहा है सबका ये? Yes. Are you getting the same? Correct. So if you're getting the same, then see, what is the restriction given to us in the question? Restriction is only 3 bars we can have in one row and maximum you can have 6 rows. That means maximum we can have 6 number of bars. Maximum we can have 6 number of bars. चलो जी 6 number of bars चाहिए तो ये 12 mm वाला तो हो नहीं सकता है. This is not possible because minimum we required 14.15. This also not possible because minimum we required 7.96. Now the only possibility we have with the 12 mm bar, 20 mm bar, because in the 20 mm it is less than your 6, right? Now always remember you have to round this to the higher digit always. So this should be your 6, this should be your 8 and this should be your 15. You should always round to the higher figure, because if you round to the lesser one, then the actual requirement will going to be less. So if you write this as 5 by 4, 20 square into 5, how much it will be? How much this value is going to be? This is going to be 1570 mm square, which is less than your 1200 mm square, and hence you are not meeting the criteria. So even if it is 5.001, then also you have to take 6. Because we have to exceed the given number. Yes, doesn't matter what is the decimal, it should be always higher. Clear, Kavya? Yes. So that is why, so here our answer is going to be 6 number of 20 mm bar. 6 number of 20 mm bar. Is it clear to all of you? Yes, any doubt? Clear? Sure. If this is clear, then further we will take the next is your under reinforced and over reinforced beam. Under reinforced and over reinforced beams. Now, what is the concept of under reinforced and over reinforced beam that we have to understand? See, from you might have seen in the site or actually, if you have visited any construction site, then you might have heard from, if you are doing any let's say local construction work, okay, or if the engineers are not that much experienced, what they will trying to do, what they will trying to do, they will always tell कि इसमें थोड़ा सरिया ज्यादा भर दो ताकि safe रहेगा. You put more steel in this so that it will be safe. That is a very wrong myth. That is a very wrong myth. And we should not ever fill our beam or column or a slab with more steel. More steel is not going to give us the more strength. It may turn to a different scenario. What is that scenario? That only we're going to discuss here under the under reinforced and over reinforced beam. Now, please tell me all of you, please tell me all of you, what do you want in your structure to fail first? Do you want your concrete to fail first, or you want your steel to fail first? Give me answer with proper justification. You want your concrete to fail first, or you want your steel to fail first, if any failure is happening? Kushal is saying steel because it gives warning. Okay. Dheeraj is telling steel. Jobin is also telling steel so that concrete can hold. Steel if concrete fails. Yes. If the steel should fail first, if concrete is failing first, then the entire building will collapse. Correct, Hitesh. So that is the concept we are using here, that always we should design our beams or columns or footings or any other structure such that the steel should fail first. Steel should always fail first, and concrete should never fail first. It should fail after that, or it should fail secondly. Why? Because if the steel is failing first, if steel is failing first, then it will give warning to the structure. Warning to the structure before collapse. Before collapse. Right? अगर ये मेरा let's say this is my beam. If the steel is failing, then only this area will fail. So that from here, whatever the concrete is there in the bottom, that will be chipped and that will be like, that will come out. So that area only will fail. But if my concrete is failing, that means other than this, my entire structure is failing. If my entire beam is failing, that means my structure can collapse suddenly. My structure can collapse suddenly. That is why we don't prefer our concrete to fail first. So based on that only, we have to design our structures. Then what is how we have to design, that comes under the concept of under reinforced and over reinforced beam. What is that concept? That concept is not beam under reinforced structures or over reinforced structures. So as the name is suggesting, it is under reinforced, means the steel is less. Here steel is less. Here the name is suggesting over reinforcement, means steel is more. Steel is more. Under reinforced beam or structure, if the steel is less, that means steel will fail first. Steel will fail first. But here your steel is more. That means your concrete is going to fail first. Concrete will fail first. Concrete will fail first. Now, if the structure in this under reinforced beam, if the steel is failing first, that means it will give warning. It will give warning before collapse. Here what will happen? No warning. Sudden collapse. No warning. There will be no warning, and it will be collapsed immediately, or sudden collapse will happen. So if there is a if this is giving warning, that means this particular structure will behave as a ductile. We will have a ductile behavior. But here, if we are getting the sudden collapse, that means it will behave as a brittle behavior. It will have a brittle behavior. Right? So one will have the ductile behavior and other one will have the brittle behavior. Clear? So in this case, what will happen? Your steel will reach the permissible limit first. And here your concrete will reach the permissible limit. Will reach the permissible limit first. Right? Now, that is why the IS code is clearly recommending you should never ever not to use over reinforced sections. We should not use which sections which are having extra reinforcement, or in that the reinforcement is becoming over reinforced. We should always use your under reinforced section. Clear है difference between over reinforced and under reinforced sections? Yes, please tell me if you have any doubt. Correct. Now, if this is clear, then further we will go. That is your singly reinforced and doubly reinforced beam. Singly reinforced and doubly reinforced beam. Now, what is singly reinforced? What is doubly reinforced beam? That we have to study. एक काम करते हैं. Let us take a break of 10 minutes. We'll continue at 8:25. Then we'll start with this topic. Okay? Please take a break of 10 minutes. Okay, so let us start the class back. So we have another two types of the beam, that is singly reinforced beam and doubly reinforced beam. Now, till now we have seen that if we are providing the reinforcement like this, that is called as your singly reinforced beam. We are providing reinforcement only in one side. But if we are providing the reinforcement in the two side like this, that is your doubly reinforced beam. So in singly reinforced beam, the reinforcement is provided only in tension side. Whereas in the doubly reinforced beam, the reinforcement is provided in both tension and compression. अब आप पूछोगे सर ये क्या बात कर रहे हो आप, कंप्रेशन में क्यों प्रोवाइड करवा रहे हैं? वी डोंट नीड एनीथिंग इन द कंप्रेशन. दैट इज ट्रू. Compression we don't need any reinforcement. Then why we are providing? For that, our architects are only responsible. Why they are responsible? Because why do we need the doubly reinforced beam? Because in some situation, what happens? Let's say, you are designing some structure, and in that structure, architect tells that in a particular room, if this is my room, I don't want this middle beam to be more than 300 mm in the depth. 300 mm in the depth. If this is the depth of the beam, architect says, no, I don't want more than 300 mm depth, so that I'll restrict my fall ceiling up to that height, and it should not be visible. Then put some kind of restriction due to the aesthetics. ठीक है भैया, मान लिया एस्थेटिक्स है. एस्थेटिक्स की वजह से स्ट्रक्चरल इंजीनियर सफर करता है. Why they suffer? Because they have to provide the strength. Structural engineer have to provide the strength. Now, provided that the beam depth is restricted and you are not getting the much strength using the singly reinforced beam, then you will provide the doubly reinforcement beam in a such a way that you are putting the reinforcement in the compression side and you are enhancing the compressive strength through the steel itself only, because steel is strong in both tension and compression. That is why we provide our doubly reinforced beam. So we'll write here a doubly reinforced beam is provided or doubly reinforced beam is provided when there is a restriction on the dimension of the beam and sufficient bending strength is not achieved using the singly reinforced beam. See, we have written this formula, right? MOR, moment of resistance, is equals to 0.36 FCK B into XU D minus 0.42 XU. Right? Now, for example, you want to achieve 100 kilonewton per meter. This much moment of resistance you want. But in the other end also, what you are doing, you are restricting your this and this. You are restricting this and this. Due to that, your neutral axis depth will also be restricted. Due to that, your neutral axis depth will also be restricted. Now, in that case, what you can do? You can increase the grade of concrete to achieve the higher bending moment. Now, if you are increasing the grade of concrete, that also have some limitation, right? If let's say I am designing my building for M20 grade. If I go to higher grade, let's say M30 grade, my cost will increase by at least 1.5 times. And the cost simplification will come. Then what I can do? I don't want to increase my cost like that much. Then I can do that. I can increase my area of steel. Here also, if this is fixed, and this is fixed, then only this is the variable which if I increase, then I increase my moment of resistance. So that is why in some cases, when there is a restriction on the depth of the beam or the dimension of the beam, then we have to use the doubly reinforced beam. Is it clear to all of you? Please tell me if it is clear to all of you. Why do we use the doubly reinforced beam? Clear, guys? Shall we move ahead? Perfect. If this is clear, then the next topic we will see is your limit state of collapse for shear. Limit state of collapse for shear. See, we have seen how to design for the bending moment. Now we will see how to design for our shear force. So if this is your, let's say, simply supported beam, subjected to UDL like this, for this UDL, we get our SFD like this, and we get our bending moment diagram like this. Correct? Now, if this is my SFD and BMD, and this is my beam, please tell me where you will get flexural crack, where you will get first flexural crack and where you will get first shear crack in the beam. What is the location of flexural crack and the shear crack? क्या लोकेशन होगी? जहां पे मैक्सिमम है. Flexural is due to the bending moment. So bending moment कहां पे maximum है? The bending moment is maximum in the middle. Bending moment is maximum in the middle, right? So you will going to get your first flexural crack in the middle span at the bottom. Why at the bottom? Because tension is generated at the bottom. Tension is generated at the bottom. So this is going to be your flexural crack. Where you will going to get the shear crack? You will going to get the shear crack where it is maximum. It is maximum at the support. So here you will going to get the shear crack at the support like this. This is your shear crack. This is your shear crack. Now, crack is developed due to the tension, right? Now, to resist this tension, what we are doing? We are providing our reinforcement. We are providing our tension reinforcement due to the bending moment. So where we provide our reinforcement, we provide in the middle span like this, to resist these cracks. So to resist the flexural crack, main reinforcement is provided. Main reinforcement is provided. And to resist the shear cracks, the shear cracks are generally developed like this, in a diagonal shape. Okay, like this. To resist these cracks, we will provide our shear reinforcement like this. This is mine. To resist the shear crack, shear reinforcement that we call as stirrups. Shear reinforcement is provided. Shear reinforcement is provided. So you might have seen, अगर कभी कोई construction site पे गए हो, तो you might have seen that if this is my beam, in the bottom we provide the main reinforcement like this, and we provide the rings which we call as a stirrups like this. Like this. And some hanger bars. Hanger bars are the minimum bars which we provide on the top so that we can connect all of them. So if you draw a cross section of this, you will get like this. Let's say 3 bars in the bottom and you have a ring like this. this is your stirrups. And this is your main bar. This is your stirrups. This is your main bar. Like this, we provide our reinforcement in the beam, shear reinforcement and the main reinforcement, or we call that as a tension reinforcement also. क्लियर है? कोई डाउट इसमें किसी को? Yes, guys, is it clear? If this is clear, then we will see how to design for our shear reinforcement. Design for shear reinforcement. So for that, the first step will be step 1. Find out the nominal shear stresses in the beam or in the structure, whatever you are using. Now, what is the nominal shear stresses? Nominal shear stresses tau V. We represent by tau V. Tau V is equals to VU divided by the area B into D or B into H, whatever it is. Right? VU is your maximum shear force. So if this is my shear force diagram, so this is my VU. Right? Divided by B into H, area of the beam. That is how we calculated our shear stresses when we were studying the shear stresses topic. So that is your nominal shear stresses. This much shear stresses is coming in your beam. Now, this much shear stresses you have to resist. How you can resist this much shear stresses? To resist that, we will check step 2. Check if tau V is less than tau C or tau V is greater than tau C. Tau C is your shear strength of concrete. Shear strength of your concrete. Your concrete itself is having the strength to resist some of the shear force. How concrete is getting the shear strength? See, if this is my concrete, if this is my concrete, and if my shear force is acting like this, so what it will do, this my shear force go through the beam like this. Like this, either in the upward direction or in the downward direction, or maybe like this. Like this. Right? Now, this aggregate which is there, these aggregate interlocking. The aggregate interlocking will resist the shear force. Right? Due to the aggregate interlocking, so if this is, let's say, if I cut my section like this, so if this is my shear force going upward or going downward, so it will create a friction in the beam. So that friction will be resisted by the aggregates present there, like this. Right? So that aggregate interlocking is nothing but that is contributing to your This is giving us, this is giving the shear strength of concrete, which is defined as tau c. So concrete itself will have some of the shear strength. Now, if with the provided loading, you are getting that your tau v, that means the actual shear strength which is required to be resisted, is less than your tau c, then in that case, we don't need any shear reinforcement. So if my tau v is less than tau c, tau v is less than tau c, that means the shear stress is less than shear strength of concrete, then no need of design for shear, no need of design for shear reinforcement, comma, concrete itself will take the shear stresses. Concrete itself will take की जगह resist लिख लो. Concrete itself will resist the shear stresses. Will resist the shear stresses. But if the applied shear stresses tau v is greater than tau c, the applied shear stresses is greater than the shear strength of concrete, then there is a need for shear reinforcement. There is a need for shear reinforcement, right? So when our tau v is less than tau c, we don't design for the shear reinforcement. Our concrete is sufficient enough to take that much shear stresses. But IS code says even if your concrete is that much strong, you please provide minimum shear reinforcement. Minimum shear reinforcement is provided because we may have some accidental load. We may have some accidental load due to the wind load or due to the earthquake load. Sometimes the load amount may get exceed and this tau v may become greater than tau c for some duration. For that, you please provide some minimum reinforcement. That minimum reinforcement should take care. Whereas when this is exceeding the nominal capacity, then we have to then design for the shear reinforcement. Design for the shear reinforcement. Now, what is the value of this minimum reinforcement? Very simple. As per IS 456, SV is equals to 0.87 Fy ASV divided by 0.4 times B. And if we have to design, so as per IS code, SV is equals to 0.87 Fy ASV into D divided by V VUS. Now, here what is what, that first we will write. Then I explain you how this formula is developed. Here, Fy, you already know, grade of steel. ASV, area of steel in shear. Area of steel in shear. SV is the spacing of shear reinforcement. Spacing of shear reinforcement. B is your width of the beam. D is your depth of the beam. D is your depth of the beam. VUS. VUS, it is nothing but shear force left to be resisted by the shear reinforcement. That means your force is nothing but your force is equals to stress multiplied by the area. Right? How much stress is left? So you have tau V minus tau C. This much stress is left. If your tau V is, let's say, 0.9 MPa and your tau C is 0.3 MPa. So 0.3 MPa is already being taken care by the concrete. The remaining will be 0.7 MPa that has to be resisted. So that stress multiplied by the area, P into D. That is going to be your VUS, the shear force that has to be resisted by the shear reinforcement. These are the terms we have here. Now, see, these formula you need not to remember. These formulas you need not to remember. They'll not ask you in the exam, but I told you the process of how do we design for the shear reinforcement. We calculate the spacing. For example, if I say the required shear reinforcement area is 400 mm square. What is the spacing for 8 mm two-legged shear stirrups? The required area for shear reinforcement is 400 mm square. What is the spacing for 8 mm two-legged shear stirrups? How we will calculate the spacing? See, very simple, very easy. Your spacing is nothing but SV is equals to the whatever is your, first understand this. If this is my beam, okay, in this beam, if let's say this is the shear reinforcement you are providing, this is the shear reinforcement you are providing. So this shear reinforcement is two-legged. Two-legged means it is having two legs. One is this and another one is this, right? So what will be the total area? ASV. ASV will be 2 times pi by 4 into 8 square. Right? How much it will come? It will come as 100 mm square, right? This ASV is going to be your 100 mm square. Correct? So your spacing is going to be nothing but your ASV divided by the shear reinforcement area multiply by 1000. Multiply by 1000 because we are calculating for 1 meter width. Because we are calculating for unit width. So from here, what is your SV is going to be? So put it everything here. So this is your 100 divided by 400 multiply by 1000. So your SV is going to be how much? Please tell me. Your SV is going to be 250 mm. 250 mm. Because here this 1000 you have put it in what? Mm. This is 1 meter width. So 1 meter if you convert into mm, so that is going to be 1000 mm. So this is going to be 250 mm. That means you will going to provide your reinforcement in the beam like this. If this is your main reinforcement, the stirrups you will going to provide like this. Like this. This spacing is 250 mm. So you'll write this as at mm at the rate 250 mm. Sorry, 8 phi. Phi is the diameter. 8 phi at the rate 200 mm center to center. This is how we will represent. This is how we will represent our stirrups. See, Dheeraj, the concept is very simple. This is the, let's say, your beam is 10 meter in the length. Okay. Let's say your beam is 10 meter in the length. For a 10 meter length of the beam, you are getting a total shear reinforcement as 400 mm square. For this entire, you are getting as 400 mm square. Correct? It is given to you that you please put the stirrups of 2 leg of 8 mm diameter. 2 leg 8 mm diameter. Now, what you will do, you will try to find out the spacing for 1 meter width. For a 1 meter, you will design it. Let's say this is my 1 meter. So in 1 meter, how much spacing I am getting? So that is nothing but the spacing is equals to your area of stirrups divided by the required area multiply by your 1 meter. So in 1 meter you got 250, then you will accordingly arrange it for the 10 meter or 20 meter or 5.5 meter like that. Clear hai Dheeraj? Yes. Is this concept clear to all of you? If this is clear, then do a numerical. Question is, what is the spacing for minimum shear reinforcement of two-legged 8 mm phi for a beam of 300 mm width, for a beam of 300 mm width, full stop. Use the grade of concrete as M20 and grade of steel as Fe415. Please apply the minimum reinforcement formula and give me the value of SV. अरे डेप्थ क्यों रिक्वायर्ड है यार? मिनिमम shear reinforcement चाहिए धीरज. Why the depth is required? Please apply this formula. SV is equals to 0.87 Fy ASV divided by 0.4 times B. All of you, please tell me the answer. Just you have to put the formula here, 0.87, just you have to put the values. Fy is 415, ASV, it is 2 lagged, so 2 into pi by 4, 8 square, right? Divided by 0.4 B, B is your 300 mm. Everything you are putting in the mm. Find out SV from here. It is coming around 302 mm, right? If you are getting 300 also, that is also fine, no issue. क्लियर है? कोई डाउट इसमें किसी को? चलो, if this is clear, then there is a model provision of IS code. IS code says the maximum spacing for stirrups should not exceed 0.75 times D or 300 mm. It should not exceed minimum of your 0.75 times D or 300 mm. This caudal provision you should remember. So if the depth of this beam is given to you, then you should apply this particular maximum spacing formula, and the maximum spacing should not exceed this much. Let's say if the depth is given to you as 400 mm, then SV max is going to be minimum of 0.75 times 400 and this is your 300. ये कितना हो जाएगा? This is also 300 mm. So your SV max is equals to 300 mm. So this IS code provision you should remember. कोई डाउट इसमें किसी को? Is this clear to all of you? Chalo. So with this is about your limit state of collapse for shear. Limit state of collapse for shear. So we have seen how to design our beams for the bending moment and for the shear force. These are the major force which acts on our beam. For that we have seen how to design it. So in your exam, they will going to ask something from here and there. Some theoretical question maybe, or maybe some small formula based question. Like that they will going to ask. With this, next we will start is your design for slab. The beam design we have seen. Now we will see the design for the slab. So before starting the design for the slab, we have two types of the slab. The one is your one-way slab and we have two-way slab. The other slabs, there are many types of the slab, but the main important we have is one-way slab and two-way slab. Other slabs like we have the flat slabs, we have the ribbed slabs, all those are there, waffle slabs, and we need not to look into those. Main important is your one-way and two-way slab. First, we will see the difference between these one-way and two-way slab. Now, the difference between one-way and two-way slab is, the first difference is Ly by Lx, or if I write L longer by L shorter is greater than equals to 2. And here we have L longer by L shorter less than equals to 2. Meaning of that, if you, let's say, this is your room, okay? This is your room. So in the room, you have, let's say, one side of 5 meter and the another side is your 4 meter. Here you have the columns. Let's say these are the columns. So this slab, this is your slab. How you will design this slab? As a one-way slab or a two-way slab? So you just have to take the ratio. Ratio of the longer span divided by the shorter span. So that is 5 by 4. So that is less than 2. That means this is designed as your two-way slab. Designed as your two-way slab. So based on the ratio of the span, we design our slabs as a one-way or as a two-way slabs. Clear hai? Then the next difference we have is the one-way slab is it is supported on two edges only, whereas the two-way slab it is supported on all four edges. Like this, if this is my slab, so this will be supported on the two edges only. Two can be any side, but this will be supported on the all four edges. Support means here the load will be transferred through the two edges only, whereas in this one the load will be transferred to all the four edges. Meaning of that, if your this is the column, this is the column, this is the column here, and this is your beam. So the load will be transferred on these two beams only. Whereas in this case, the load will be transferred to all the four beams from the slab. That is how the one-way slab is function, and that is how your two-way slab is functioning. That is the number two, your difference between one-way and two-way slab. Number third difference we have is in one-way slab, the bending take place in the shorter span only. In the shorter span. Whereas here the bending take place in both shorter and longer span, because it is supported on the both the spans. One, but the other one is supported only one span, and hence the bending will take only in the shorter direction. Due to this, that the bending is taking place only in one direction, and hence the main reinforcement will be provided in a shorter direction only, because in whatever the direction the bending is happening, in that direction only we will provide the reinforcement. Here the main reinforcement is provided in both span, in both span. Is it clear to all of you? In four differences में किसी में doubt है तो please tell me. If you have any doubt in the four differences, please tell me. All clear? If this is clear, then next we will start with design of slab. Either it is a one-way slab or two-way slab. How we do the design for the slab. Step one. Step one. The thickness of the slab is determined based on the deflection criteria. Determined based on the deflection criteria and checked for bending and shear. So what we will do for the slab design, you know very well, in case of slab what is required. So if this is my room, the length and the length in both sides is already determined, right? That this much will be the size of your room. Now we only need to know the thickness of this slab. Now we only need to know how much thick this slab is going to be, right? This thickness we need to know. So this thickness is shorter span divided by the deflection ratio. Shorter span divided by the deflection ratio. Now, how much this deflection ratio we have? So IS code suggests us that I will write this as D. Will define D as the thickness of this slab, so that we can have the exact nomenclature which is used in the IS code. So this L by D ratio, L by D ratio is equals to 35 is equals to 40. L by D ratio is equals to 35 and is equals to 40. This is for two-way slab. For two-way slab. And this L by D is equals to 35 is applicable for simply supported beam. For simply supported beam. And this is for continuous beam. Continuous beam. When the grade of concrete, when the grade of steel Fe is 250. Fe is 250. And the same thing will be applicable. This is going to be equals to 28 and 32 when the grade of steel is 415/500. 415/500. That is nothing but you just have to multiply these two by 0.8 and you will get these values. Multiply both of them by 0.8, you will get the respective values approximately. So this is for the two-way slab. Now, if let's say this is 5 meters smallest span, what is your smallest span? 4 meter. So, and let's say this is a two-way slab simply supported. So what you will do, your thickness of the slab is going to be 4000 divided by 35. So you will get your answer. So this is nothing but 4000 divided by 35. That is going to be approximately around 115 mm. Like this, you will going to get the thickness of your slab. So this is true for the two-way slab. Now, what is the thickness ratio for the one-way slab? For one-way slab, we have our L by D is equals to 7, 20, and 26. This is for cantilever. This is for simply supported beams. And this is for continuous beams. Slab supported on the cantilever beam, slab supported on the simply supported beam, or the slab supported on the continuous beam. For all grades. For all grades of steel. Right? So this L by D ratio you have to remember, and through that you can get the thickness of your slab. Right? This is how our IS code is defined. Now, I will request you to only remember this one for one-way slab, which is easy and which can be sometime asked in your exam. Till now, they have not asked, but if they will ask, then they'll ask from generally one-way slab only. So for one-way slab, if you can remember, that is more than sufficient. Or else they can give you in the exam itself only. The L by D ratio for a one-way slab is 7 for this grade of concrete and this grade of steel. Please find out the thickness of the slab like that. So from that ratio, you should be able to find out the thickness of the slab. Clear hai? If the step 1 is clear, then in step 2, design or find out the reinforcement, because dimensions we got, only the thickness was required. Now thickness was required. Now we have to find out the reinforcement. So reinforcement, your same formula, M is equals to 0.87 Fy AS D minus 0.42 XU. D minus 0.42 XU. Now here, you have to find out the mu or m will be given to you. That is our bending moment. Bending moment we can find out through the loading, right? And this we have already got, this also we will get, and this will be given to us. From here we can find out the reinforcement in our slab. That is how we will going to design our slab. And based on the whatever the amount of reinforcement we are getting, we will again provide the spacing as per the same formula, that is your pi by 4 into d square or phi square divided by the given AS multiply by 1 meter thickness, so 1000 mm. So for 1 meter width, the spacing is defined in the slab. Spacing for the slab is calculated for unit width. Unit width means 1 meter width. So this is how, once you got the spacing and this is your slab, let's say 4 meter by 5 meter, so you will going to provide your reinforcement like this. So this you can write that, let's say we are providing a 10 mm or 10 mm phi at the rate of spacing of, let's say, 125 mm center to center. Like this, you will going to use this formula for finding the spacing. This is how we design our slabs. Is this clear to all of you? Any doubt? चलो आज क्लास यही खत्म करेंगे. In the next class, we'll start with the limit state of compression, limit state of collapse or compression. That is the design for the columns. And then we will see the design of the footing. And thereafter, we will do some of the previous year questions. Yes, please. Is it clear to all of you? If you have any doubt, please type it. Else, you can leave the class. Thank you. Design of shear कहाँ रह गया यार? Yeah, it's the same formula, Adarsh. That formula we have developed for flexor, na? So your beam is designed for the flexor, and the slab is also designed for the flexor. So whenever we are talking for the flexor, the formula will remain same for if you are designing for beam, column, footing, or slab anywhere. The formula will going to remain same. So while calculating the number of bars in decimal, we round up the number of bars. Would that be considered as a over reinforced? No, that is how over reinforced is not being considered. That is how it is not being considered as a over reinforced. Meaning is, let's say your requirement is of 600 mm square, okay, and you are providing 1200 mm square. That is over reinforced. That is your over reinforcement. Under reinforcement means if my concrete is, let's say concrete can resist up to 200 mm square and I'm providing 1200 mm square in steel. that is over reinforced, that is under reinforced. Of this 1200, if you are providing 1300, then also it is fine. 1600, then also it is fine. But this 1200 mm square, if you are going up to double of this, then it may become a over reinforced beam. Clear hai, Kavya? Sir, from truss. So it need to be significantly high or low value? Yes, absolutely. Dheeraj is saying, sir, from truss for method of section, do we need to choose 3 unknown force members or 2? It depends on you, यार. अगर आपको 2 मिल गए तो 2 चूज कर लो. जरूरी नहीं है 3 ही चूज करना. If you are getting 2 only, you choose 2 and solve it. But maximum you can solve the 3 unknowns. Clear है धीरज? Maximum you can solve 3. Minimum तो it is up to you. Others, sir, I have seen SV being inconsistent throughout the span in some structural drawing in the site. How does that happen? देखो सिंपल सा फंडा है आदर्श. See, this is your shear force diagram. Correct? This is your beam. Now, where is the maximum shear force is happening? At the support. So, at the support, you will provide the less spacing. Less spacing means more shear reinforcement. So, at the support, you are providing a tight spacing. Let's say you are providing 8 at 100 mm. But in the center here, you don't require much shear reinforcement to be resisted. So here you will provide more spacing like this. Let's say 8 at 300 mm center to center. That is why it is not consistent. Clear? चलो आज क्लास को यहीं क्लोज करते हैं. Thank you all of you. Yeah, thank you. Okay, so good evening to all of you. Yeah, good evening, guys. Chalo. Shall we start our lecture? Perfect. So let us start the lecture. So in the last class, we were discussing about your limit state of flexure, limit state of shear, and we discussed about the design of beam, design of your slab. So today we will start with limit state of collapse for compression. Limit state of collapse for compression. Now, as all of you know, compression is generally used for the columns. So for the design of the columns, we will see here itself only the design of your column. Just give me a second. So in this chapter only, we will going to see the design of column. Design of column. So our column is mostly subjected to the compression force. There will be no tension. So it is generally subjected to your compressive force. Along with you may have the bending moment also. So you may have the bending moment also, M, acting on the column. So column is generally designed for the compressive forces and the bending moment. Now, first, for the limit state of compression, what are the assumptions that we have to look into? Those assumptions we will see. So the first assumption we have, so assumptions. So the number one assumption we have is your plane section before bending should remain plane after the bending. The same thing which we studied in our bending stresses. So plane section should remain plane before and after bending. Before and after bending. Number two, the maximum compressive strain. Maximum compressive strain in the concrete for axial compression only is 0.0020. 0.0020. But the maximum compressive strain in concrete for your axial compression plus bending, if the bending is also acting with the axial compression, then it is or is 0.0035, which we studied in our bending analysis. So when the bending is also acting with the compression, then your strain is going to be the same, 0.0035. But if only compressive force is acting, then your strain is going to be 0.0020. If compressive force plus bending moment is acting, then it is going to be 0.0035. So this is the second assumption, and this is the third assumption. These two becomes important, and these can be your direct objective question. These can be your direct objective question. The fourth assumption we have is if your slenderness ratio, that is L by B ratio, if that is less than 12, then it is called as a short column. And if your L by B ratio is greater than 12, then it is called as a long column. Okay, just give me a second. So we were discussing about your L by B ratio. So for the column, if your L by B ratio is less than 12, then it is called as a short column. Less than equals to 12, then it is called as a short column. If L by B ratio is greater than 12, then it is called as a long column. Okay, this also becomes important. They can directly ask as an objective question, right? So you should remember this. Then the fifth point which we use for our design is the axial, or if I write as pure axial compression capacity of column. So column capacity, that means what is the axial force we can have? PU, the maximum axial force a column can have, is equals to, PU is equals to your 0.45 FCK into AC plus 0.75 Fy into AS. So this is a very important formula. They can directly ask a objective question from this, and they have asked in previous year also. So here, this your 0.45 FCK, this is nothing but this we call as sigma CC. That is your stresses in compression in concrete. Compression in concrete. So what is the stresses in concrete we are getting? That is your sigma CC. Multiply by AC. AC is your area of the concrete. AC is your area of concrete. Then this 0.7 Fy we call as sigma. S is for steel. So sigma S. So that is your stresses in steel in column. And AS is the area of steel. So for example, if this is your cross section, this is the width, this is the height, and let's say like this, we are providing the reinforcement in the column, right? On the top and the bottom, we are providing the reinforcement in the column. So the total capacity of any column is going to be, the PU is going to be P of concrete plus P of steel. How much my concrete can resist the axial force and how much my steel can resist the axial force. That is nothing but that is your pure axial compression capacity. Now here your P concrete will become as your sigma CC into AC, and your P steel will become sigma S into AS. So in the exam, they can either give you directly the value of sigma CC and sigma AS, and they can ask you the question, or they can give you the value of the grade of the concrete and the grade of the steel. Then you have to find out these values. Right? With this, you just have to remember this formula, and it was asked previous yearly. So you should remember this formula. They may ask again. A very basic formula. Now here, I mind you, most of the people make a mistake here in finding out the AC. AC is the area of concrete. Okay, so the area of concrete is going to be equals to B into H. That is the gross area minus area of steel, because here you have the steel. So this steel you have to minus from the total area, from the gross area. B into H minus AS. That is going to be your sigma CC. धीरज पूछ रहा है sigma is different from Fy divided by 1.15 which we used earlier. Yes, Dheeraj, it is different because that whatever we used earlier, that was for the flexor only. That was for the flexure only. But this one is for the compression. So your steel is more strong in the compression, but it is strong in tension also, but is lesser than the tension value. It is strong in compression, but lesser than the tension. That is why the more factor of safety is provided here, and that is why it is reduced from 0.87 to 0.75. Okay, so this formula you have to remember, and you have to design your column accordingly. क्लियर है? कोई डाउट इसमें किसी को? Is it clear to all of you? Okay, if it is clear, then design one of your column. Question is, find out the axial compression capacity of a column of 300 by 400 size, given that the grade of concrete is M20 and grade of steel is Fe 500. Also, the area of steel is, let's say, 1600 square. 1600 square. Please solve this. Kushal is saying it is 0.67 or 0.75, as I studied 0.67 in college. अरे भैया थोड़ा इंतजार करो, विल कम टू दैट आल्सो. थोड़ा इंतजार करो, सब्र करो. Okay, Kushal, थोड़ा सब्र करो, विल कम टू दैट आल्सो. First, solve this question based on the whatever formula I have told you. Kushal, first solve this, we'll come to that formula. Okay, 0.67 वाले फॉर्मूले पे भी आएंगे. Find out the axial compression capacity of the column. All of you, please solve it and give me the answer. Your answer should be in kilonewton. Your answer should be in kilonewton. All of you, please find out. 1665. धीरज आपका इतना कम क्यों आ रहा है यार? 1665 is the correct answer. 1665 is the correct answer. Yes, other people, are you able to solve it? धीरज ऐसी गलती करोगे तो कैसे कैसे काम चलेगा? They are doing such mistakes. How it will work? These are called as a silly mistakes. Chalo, all of you please see here. See what is given to us. It is given to us. We have a 300 by 400 column. This is the area of steel. It is given to us as AS is equals to 1600 mm square. So first you calculate the area of concrete. So area of concrete is going to be 300 into 400, that is the gross area, minus 1600, right? So this is going to be your equals to 118400 mm square. That is the area of concrete, right? Now area of steel is given to you, area of concrete is given to you. Simply apply the formula. Pu is equals to 0.45 FCK AC plus 0.75 Fy multiplied by AS. Put it here. So Pu is equals to 0.45. What is your FCK? M20. AC is 18400 plus 0.5 times 500 into AS is 1600. So from here you will get Pu is equals to 665 into 10 raised to the power 3 Newton. Now if you want to convert this into kilonewton, this is going to be 665 kilonewton. क्लियर है? कोई डाउट इसमें किसी को? Please tell me if you have any doubt. Sure. If this is clear, see here I have written the point number 5 is this is for a pure axial compression. That means there is only axial force is acting. There is only axial force is acting, right? Now, point number 6 in the assumption, what if your axial force and the moment is also acting? If axial force, if axial force is acting with bending moment, in that case, your Pu is going to be 0.40 FCK into AC plus 0.67 Fy into AS. In this case, further we will reduce our concrete strength and our steel strength. The reason is very simple, because a moment is also acting with the beam. Now this moment can be sagging, can be hogging. So it is quite variable. So that is why we are further reducing our factor of further reducing our uh, strength of the concrete and the steel. So this is the formula that you have to use when the axial force is acting with the bending moment, and this is specifically for small eccentricity values, or for more eccentricity, for small eccentricity. Now, what do I mean by eccentricity here? Eccentricity is nothing but your bending moment divided by the force P. If this eccentricity is less than 20 mm, then you apply this particular formula. That means if your axial load is acting with a minimal bending moment, then we will going to use this particular formula. क्लियर है? किसने पूछा था? आदर्श, किसने पूछा था? Kushal, is it clear? So one formula we have to use when we have only the axial compression, and one we have to use when we have the compression with the bending moment or with the moment. So this is how we design our column. For the column designing, what we have to do? Nothing much. We have to calculate the capacity of the column. We have to calculate the capacity of the column, and that we can do. Yeah, that we can do very easily if we know the properties. If we know the properties. क्लियर है? आगे चलें, कोई डाउट इसमें किसी को? चलो, this is clear. Then next we have is your design of the footing. Design of footing or foundation. Design of the footing, or you can call this as a foundation also. Now, first we will see what are the types of footing we have. Types of footing. So the first type in the footing we have is called as your isolated footing. First we have is your isolated footing. Then we have, second we have is your combined footing. Second we have is your combined footing. Then third we have is your strap footing. Fourth we have is your raft. Raft foundation or raft footing oblique mat footing. Mat footing. These are the four major types of the footing. Okay. Now, before going and discussing these types, we should know that footing is categorized based on the how much at how much depth it is located. So footing is generally categorized as shallow footing or deep footing, or the shallow foundation or the deep foundation. Shallow foundation, and we have deep foundation. Shallow foundation and deep foundation. So under this category of shallow foundation, we have these type of footings. Under the category of shallow foundation, we have these type of footing. And under the category of deep foundation, we have number one is your pile foundation. Number one is your pile foundation, which is a major foundation for our what we call it, for the deep foundation, right? Then we have your, let's say, uh, what are the other examples you know for the deep foundation other than the pile foundation? Please tell me. डीप फाउंडेशन और कौन कौन से देखे हैं आपने? केजियन फाउंडेशन, केजियन बोलो या वेल बोलो, एक ही बात है. केजियन फाउंडेशन. Any other thing which you can correlate and tell me? Coffer dam is not a foundation. Foundation is the one which is below the surface. Shaft foundation is nothing but a type of pile foundation system. Strip foundation तो आ गया ना यार इधर. Here we have fifth, यहाँ पे लिख लो strip foundation. Strip foundation. These are the type of foundations we have. Now, how to differentiate between shallow foundation and deep foundation? Very simple, very easy. Let's say if this is your foundation, this is the depth of foundation, and this is the width of the beam. This is the width of the beam. So, for a shallow foundation, your B should be less than DF. D should be less than DF. That is your shallow foundation. And for deep foundation, if your, sorry, ये उल्टा लिख दिया. DF is greater than less than B. I'll write it here in the bracket itself. So that is your DF is less than equals to B here if your DF is greater than B. DF is the depth of foundation. So if DS is less than the width of the foundation, then it will remain as a shallow foundation. But if DF is greater than the value we have to take. So DF is less than equals to B for the shallow foundation, and DF is greater than B, then we have the deep foundation, right? Now let us go one by one for these foundation. I'll take the values also if required. First, let me explain you what is your isolated footing. So in isolated footing, what we have? Very simple. If like we have a footing like this, footing for one column. So this is my column. For this one column, we have the footing, right? That is your isolated footing. So like this, you can make also. For one column, we have one footing. Correct? That is your plan and this is your elevation. Combined footing means like this if we have. That is footing for two or more columns. Footing for two or more columns combined together, right? Then we have a strap foundation. Strap foundation में क्या होता है? We have, let's say, two columns. These are my two columns. These two columns are joined by a strap like this. That is called as your strap, and this entire will be called as a strap footing. Entire will be called as a strap footing. Right? The next we have is your raft oblique mat foundation. So raft and the mat foundation, what do we do? For the entire area, let's say, if I'm providing for the entire area, let's say if I'm providing the footing, that footing will be your raft foundation. So this is a raft foundation located on, these are the, let's say, your columns. Then next we have, so here we can write that raft foundation oblique mat foundation, it is used when the soil pressure is not good enough. It is used when the soil pressure is not good enough to resist the it is used when the soil pressure is not good enough to resist the stresses due to it is used when the soil pressure is not good enough to resist the stresses due to columns supported on it. Columns supported on it. That is your raft foundation. Then we have a strip foundation. Strip foundation. So in case of strip foundation, what do we do? This is my strip foundation. For the walls which are continuous in nature, comma, strip foundation is provided. Strip foundation is provided. This is your wall. You might have seen generally कोई boundary wall अगर आपने देखी होगी, right? So for that boundary wall, we provide your strip foundation only. क्लियर है? कोई डाउट उसमें किसी को? Any doubt, guys? Clear? Then similarly, we have your deep foundation, right? For the deep foundation, okay, I'll write down. For the deep foundation, we have your pile foundation. Pile foundation is used when soil is weak at surface and the load is very huge on the structure. Load is very huge on the structure. So what do we do? Why do we provide the pile foundation? Because if let's say this is my soil, here we will going to have the very weak soil. In case of let's say filled up soil, or in case of some sandy or clay soils mixture, that doesn't represent a high strength soil. So in that case, what we will do, we will provide piles to such a length so that we get a good hard rocky surface. Good hard rocky surface. So that our capacity can be increased. This is my pile. This is my pile. Then next we have is your Caesian foundation. It is nothing but it is used for making the structures in the water. So for water bodies, let's say if we are making the bridge, example, bridge over a river. So for that, whatever the foundation we will going to use is your Caesian foundation. Caesian foundation is nothing but what do? We make a circle kind of thing in our, let's say, water body, and there will be the sheets all around this. So these sheets will penetrate directly, and it will we have to penetrate till we reach the rocky surface. So outside you will have the water, and this particular hole will create the vacuum all around it. So whatever the water will be there, we will take that water out. And then we will fill the concrete inside it. And accordingly, we will design our Caesian foundation. Clear hai? कोई डाउट इसमें किसी को? हाँ, बीच में एक डाउट आया था ना, क्या डाउट आया था सर? इसेंट्रिक फुटिंग. Eccentric footing is nothing but the footing which is subjected to the axial force and the bending moment. That is the eccentric footing. The one which have the eccentricity in it. Okay. For example, let's say you are providing a column near to your boundary line of the your house. So you cannot go in the right direction, in the left direction. Then what you will do? You will provide a footing like L shape. Now, if you see, the CG of this particular footing may be lying here. So here we will get the P load, and due to this P load, here we will get some moment. Here we will get some moment. Right? That is nothing but that is your eccentric footing. Like the KCL foundation is many way, yeah. In the Taj Mahal also, new whatever the pieces we are making, like your Bandra Borivali ceiling, all those are made through your KCL foundation only. क्लियर है? आगे चलें डिजाइन की तरफ. Shall we move ahead for the design? Sir, in huge high-rise building, pile foundations are preferred. Not only preferred, pile foundations are only provided. Your Burj Khalifa, the tallest building in the world, in that they provided like many piles. I think it is more than 2,000 or 3,000 piles are there for constructing the Burj Khalifa. So depending upon the load and the soil capacity, we have to provide the pile foundation. Clear? The difference between combined and strap footing, yeah, that's a good question. See, what we do here, this is my combined footing. Let's say these are the house. This is my house and these are the columns in my house. Okay. These are, let's say, columns in my house. Like this I have, for example. Now here, what is happening? A combined footing is the footing which we make by taking two columns together, which have the use load. Through that we will make the combined footing. Now, but in case what happens, one of your column which is on the boundary line, let's say, is having more load, and the one which is near to it is not having that much load, less load. Then what we can do, rather than providing a combined footing like this, we can transfer the load of this to this particular column by just providing a strap footing. So that what will happen? So what will happen with this strap? See, number one thing, this strap is less in thickness than the combined footing thickness, and hence we will save the cost. When there's not much load is there and it can be transferred through a small this kind of strap which will save our cost, then we will use the strap footing. Clear hai? So that the load from here can be transferred to this particular footing. Is it clear, Ishpreet? Chal. Now let us go into use during the construction of row houses. Yes. These are the like day-to-day basis footings that you may see in the construction. Now let us go to the design of the foundation. design of footing or foundation. See, in case of design, what is required? Nothing but, let's say, if this is my footing, this is going to be my length, and this is going to be my, let's say, width. So I need to know what is my length, what is my width, right? That is the number one thing we should know in our design, right? Number two is how much should be the thickness of the footing. So this is the thickness of the footing. How much this thickness should be there. This also I should know. Then the third point becomes how much reinforcement we should provide in the footing. This reinforcement. So number 3 point is your reinforcement. Reinforcement in the footing. If you know all these 4 things, that means you can design the footings. You can design your footing very easily. So the first step is step 1. Finding dimension of footing. So your area of footing is going to be equals to the maximum load on the footing. Maximum load on the footing, let's say that is in kilonewton, divided by soil bearing capacity, that we call as SBC. This capacity is in, let's say, kilonewton per meter square. So kilonewton and kilonewton will get cancelled out. You will get the area of footing. You will get the area of footing. Right? Now, your question is, what is soil bearing capacity? Very simple. See, if you are putting your footing like this, so this footing is going to transfer its load to the soil, right? The soil which is below here. So this soil is going to give you equal and opposite pressure on your footing. That pressure is nothing but that is the soil capacity. That means if I say my soil capacity is, let's say, 200 kilonewton per meter square, that means my soil can handle a load up to 200 kilonewton per meter square. So SBC will be given to you in the exam. SBC will be given to you in the exam. Maximum load also will be given to you in the exam. You just have to find the area of the footing. Now here, if it is a square footing, then your area is going to be B into B. If it is a rectangular footing, then area is going to be L into B. These 2 things you should know here. Clear here? Now, if you put this B into B, L into B on this formula, you can easily get the width of the footing and the length of the footing respectively. Now, generally, they will give you in the exam that consider that L by B ratio, length by width ratio is, let's say, 1.2 or 1.3, like that. 1.2, 1.3, 1.45, something like that they will give you. So based on that, you can calculate length and width of the footing. Since you will get the area from here, the remaining value you can easily calculate. Naman is asking, is factor of safety taken into consideration while calculating SBC? Yes, SBC is your ultimate SBC. This is your ultimate capacity. So factor of safety is already taken. See, we are writing here maximum. That is the load. And this is also your maximum soil bearing. Soil bearing capacity itself is the maximum. Clear है? और कोई डाउट इसमें किसी को? Now, your step 2 is going to be, thickness of footing. Thickness of footing. So your thickness is calculated the thickness is, it is calculated using the one way and two way shear concept. One way and two way shear concept. Now we will not see the formula for how we calculate the thickness of the footing, right? You just need to remember that it is calculated using one way and two way shear concept. Very simple. The concept is very simple. If this is my footing, so my one way shear occurs when the one way shear occurs at a distance d by 2 from the center. At a distance d from the center. That is for one way shear. At this location, the one way shear will occur. But whereas the two way shear occurs at a distance of d by 2 from the center of this column. Okay, so that is your two-way shear. That is your two-way shear. Or also we call this as a punching shear. We call this as punching shear. So we'll not go into the formula for how to calculate this thickness of the footing, because you need not to remember that, right? Only thing you should know what is the concept which is used for calculating. So that is one way shear and the two way shear. So two way shear is calculated at a distance of d from the center of this, and d by 2 for the two way shear and d for the one way shear. Right? Now, if you got the thickness of your footing, then your AS you can easily calculate from our formula. Mu is equals to 0.87 Fy into AS into D minus A by 2. So here again, this is the generic formula, right? AS you have to find out all the other things. This is D minus 0.42 Xc. D minus 0.42 Xc. So all the other things will be given to you. Only you have to find out the AS, because depth you will know, the XU you will know, the grade of steel you will know, and MU you will know. So from here you can find out the AS. From here you can find out the AS. Okay, so this is about the design of your footing, and in the design you just have to know how to calculate this particular thing, how to calculate the dimensions of the footing. So this particular question is being asked in your exam 2-3 times, so you should remember this. क्लियर है? कोई डाउट इसमें किसी को? Yeah, x is the distance from neutral axis. Last class में बताया था. Yes, is it clear to all of you? Okay, if this is clear, then we'll do some we'll take some of the previous year questions.